It's a great source of discovery. If you want to get discovered, I say start streaming to YouTube. Okay, let's see if we get this going. I don't see any encoders yet. Connected. Okay, cool. Good. Okay, we're up and running, but where is it? There we go. Cool. Dun, dun. There we go. Okay, cool. All right. We're holding steady. I'm happy. Let me do one little test on the things. How did you get so good? Get so good at what? What did I get so good at? Please tell me. And then here. Welcome, YouTube. How did I get so good at school? Oh, just a lot of like perseverance, man, honestly. I was lucky to have parents who were pretty concerned with my education, which I know not everyone has the gift of that. But yeah, just a lot of just doing stuff. Is this a plug and chill problem? Yeah, let's see. The following relates the volume and surface area of a sphere. Wow. Yeah, this might be just a plug and chill question, honestly. Find the volume to the nearest cubic meter of a spherical holding tank with the surface area of 100 meters. This is just like a plug and chill. This is a plug and check question for sure. Yeah. Let's actually try to see where this comes from, though. I mean, this is fun that they gave this to us. I think the main thing here to realize is that anything to like the negative 1/2 is the same as 1 over that to the 1/2, and 1/2 powers are like square roots. So this is the same as like 1 over the square root of a. This is kind of the important part of fractional exponents. What do they call it? Rational exponent. I call them fractional. I know they're technically rational. Where this comes from, though, this is actually interesting. The volume and the surface area. So here, there's actually some cool question, right? So volume of a sphere is 4/3 pi r cubed. Whereas surface area, which they're calling S, is equal to 4 pi r squared. Integral of the upper hemisphere coming up. Okay, here we go. That's when things get a little bit more difficult. Yeah. All right, so if you wanted to relate this to this, right? This is actually kind of cool here. Nice. Okay. So let's see. I could like separate this out a little bit. Oh, so we got rid of the cubed. So this is the same thing as 1/3 times, and this is 4 pi r squared, sorry. 4 pi r squared times r. Interesting. And then I could just replace this with s if I wanted to. They have like s to the 3/2. Why are they doing that? Oh, this is actually kind of interesting how they're doing this. Wow. Watch this. So they're saying s to the 3/2 is the same thing as 4 pi r squared to the 3/2. This is actually kind of a goofy way to write this. Right, they have r not appearing at all. Yeah, exactly. And the reason for that is that if this were to come inside, right, and hit everything, you would have 4 to the 3/2 pi to the 3/2, and then you'd have r cubed, which is what you want eventually, right? Oh, that's so goofy. Okay. You could also solve for r and plug in for volume. Okay. I kind of like that. Yeah, let's do that. That's actually kind of a cooler way to do it. Let's do it. I'm just curious, like, I know where this equation comes from, and it's just such a goofy way to write it. Okay, so then r is equal to s over 4 pi. And that's r squared. Oh, I see. So that becomes to the 1/2. Uh-huh. Okay, Jeff, I'm seeing. And then we're going to plug that into here. So you get v is equal to 4 over 3 pi. And now this is this stuff to the 3rd. Oh, wow. Okay, cool. Here, let's move this down. This is all to the third, yeah, right? Okay. And then what we learn about is if you have exponents, two exponents, you multiply the exponents together.
My man.
So this is just going to be 4/3 pi. And then that's s to the 3/2, right? And then it's 1/4 pi to the third, which is this to the 3/2, sorry. So that's the same thing as 4 pi to the negative 3/2. So if I wanted to flip this, right? That's 4 pi all to the -1. Okay. Oh, and I see where this comes from now, because watch this, watch this. So now you have 1/3, 4 pi, s to the 3/2, and then you have 4 pi. Why does the exponent affect everything inside while multiplying by a number only affects one of them? That's a good idea. That's really good descendant fonts. Yeah, let's talk about that. That's actually a kind of cool concept. So this would be to the negative 3/2, and then you have a 4 pi here to the first. Oh, this is cool. Now you can combine these two things. And so this is the same thing as 4 pi to the 1 minus 3/2, which is the same thing as 4 pi all to the negative 1/2. Yes, JC. Yes, thank you. Appreciate it, Jordan. You're Jordan in my, I think, are you Jordan? Sorry, you're Joseph. Joseph in my Discord, right? Okay, cool. Now I see where this comes from. Yes, cool. Thanks, Joseph. Yeah, 1/3, 4 pi to the negative 1/2, s to the 3/2. Yeah, nice. Jeff says 4 times 5 to the 6 is 4 to the 6 times 5 to the 6, but note that doesn't apply to addition. Right, yeah. 4 plus 5 all to the 6 is not 4 to the 6 plus 5 to the 6. Yeah. Okay, this is where the formula comes from. That's cool. And then, yeah, to solve this, you just plug in 100, right, in for here. Which is actually kind of fun. This is actually not bad to deal with, right? Because watch, because s being 100 is actually great. Yeah, he's talking about, and I'll explain that. Okay, let me just watch this one. So if s is equal to 100, then so 100 to the 3/2 is the same thing as 100 to the 1/2 to the third. Or you could do 100 to the third to the 1/2. But 100 to the third and then to the 1/2 kind of sucks, right? You don't want to do that. This is easy. 100 to the 1/2, that's just square root of 100. That's a 10, right? So this just becomes 10 to the third. What's up, Colton? So you just get v is equal to 1/3, 1/4 pi. Well, I guess square rooted. And then it's 10 to the third. Cool. All right. And then you can do it in your calculator, but yeah. Okay, that's a cool question. Yeah, the exponent rules are interesting. And then Mistral, I see we'll do your question next, Mistral. No, I think he's talking about this. So for instance, if you do 4 times a times b, this is just 4ab. Versus if you have ab to the 4th, this is the same thing as a to the 4th, b to the 4th. He's saying, like, why does this not, like, multiply both things? Why do I not have, like, 4a times 4b? I think that's what you're coming at. You're pointing out descendant fonts, right? What do you tell students when they ask if they'll ever use this IRL? I tell them that math, like learning math, is the same thing as like going to the gym. Like when I bench press, 2 plates, do I ever in real life need to bench press that much weight? I hope not, right? I don't really do manual labor or anything, right? But the process of doing it builds up strength. And it's kind of the same thing in math. Learning to do this type of stuff in math builds up neural pathways so that you can like solve puzzles that are similar. Yeah. Oh, thank you, Official Kens. Love your videos. God bless you. God bless you too, man, dude. God bless you as well. Okay, but the reason why this happens, we're going extinct anyways.
Disqualified.
Yeah. The reason for this is so AB to the fourth is the same thing as AB times AB times AB times AB, right? This just means AB times itself 4 different times. And so if you wanted to then rearrange this, right, due to the commutative property, this is the same thing as A times A times A times A times B times B times B times B. This is A to the fourth. This is B to the fourth. And that's why you end up getting A to the fourth, B to the fourth. It's pretty cool. Okay, let's see. We do have some questions on the queue so far. I got one from Mistral. Let me go check it out real quick. A plus B to the third. Yeah, that's called the trinomial. That's a perfect cubed. Not a perfect square. Not a perfect square, right? Perfect cube. What's up, Kano? Good to see you, dude. We're helping students out with math and science. If you got a question, you want to submit it, feel free to do so. It's that website, actualofficehours.com. We'll go through the questions. For those that are just joining us today or have never done this before, yeah, just go to actualofficehours.com. You can put in your username here, and then you can drag a screenshot in and hit upload. And then if you want to view the queue, I can do spherical integrals. Yeah, I'm pretty sure I can. So you can also see like the questions. Okay, here we go. This one comes from Mistral. Has to do with Fourier signs. Yeah. Can you do IIT questions? Is that India Institute of Technology? What's IIT? Yeah, we love Fourier transforms. Okay. Determine the Fourier cosine series for 3x cubed minus 2x over 0 to 2 pi. Ooh, where does this come from? Like, how do I express this in terms of sines and cosines? Is that what we're asking? You can try Free Fire. If you want to submit a question, I'll take a look at it and see if it's solvable for me. Integrate cosine of nx times that. Okay. Yeah, I hadn't heard of like what a Fourier cosine series is. Let me check that real quick. Okay. Okay. Wait, it's cosine nx, yeah. Yeah, Fourier series, yeah, Fourier transforms are pretty cool. So you want me to integrate 0 to 2 pi of, what is this? 3x cubed minus 2x cosine nx dx? How does that work? Yeah, exactly. They're orthogonal. I understand that. Yeah, for sure. Well, if you can do Calc 3 just fine, you're great, Sebas, dude.
My man.
Okay. L equals 2 pi. F of x is that. Integration by parts? Yeah. Yeah, you could. Yeah, let's try to do that. Yeah. Because you can separate this into what? This is 0 to 2 pi. 3x cubed. Cosine nx. Plus 0 to 2 pi. Well, I guess minus, right? Technically. And then this is 2x cosine of nx. Which, yeah, you have to start doing integration by parts. The website's there. It's in the domain there. Actualofficehours.com. All right, yeah, let's do some integration by parts. I like integration by parts. So, left as an exercise for whoever asked that question. Yeah. Oh no, why did we lose our internet connection all of a sudden? One sec. Come on. Tabular method does work, yeah. I don't know why that blipped out for a second there. Right, the setup is done, but the rest is just algebra. Yeah. Oh, wait. Where did this one... I literally wrote this. Where did it just go? Okay, let's see. I don't know why this... Okay, minus... 2 at... Or here, I'm going to leave the 2 out front, too. Here, we can leave the 2 here. I'll do, like, one of these. The other one is, yeah, kind of an exercise for the reader. X cosine nx. Okay. This is u is equal to dx. Oh, is there? Okay. And this is dx. So then we'll say that dv is equal to cosine nx dx. Sorry, u is equal to x. Oh, why does this keep losing connection, dude? What the hell? One sec. That's super annoying. Okay. What should I put for the companies? What are the companies? Sorry, what? Yeah, that's the tabular method. And what is this? This is 1 over n. 1 over n. Sine of nx, right? So then this becomes uv, so x over n sine nx minus the integral of 1 over n sine nx. I think I see where, I think you see where, yeah, this would, because then this, integral of this is just negative cosine. So that's, is that plus 1 over n squared cosine of nx? Yeah, the DI method. Okay, I think that's fine. And it was minus 2 times all that, right? That's what all of this was to get into this. I don't remember the tabular method off the top of my head. Let me see if I can figure it out. One sec. Tabular method. Oh, come on, girl. Yeah, okay, this is what they talk about it. What's up, Famish? Good to see you. Yeah, because I think I want it for this one. What is this SDI method they talk about? This is the tabular method, yeah. Basically, when you know you have something, like in this case x cubed, and this is an easy one that you can just keep integrating down. It's an easier way to do this method, but to do it like really quickly. Is what they say. So I think what you do, and then s is like the sine. Oh, I see, because it keeps, because you keep having that minus integral of v to u, right? Yeah. Okay, so I think let's look at it real quick. I'm pretty sure this is how this works. Okay. S D I. Let me see. Yes, exactly. Because the original integral is x cubed, and then you have the I part is cosine nx dx. So then this becomes x squared, x to the first, 0. Or, no, sorry, 1. Oh, well, you gotta show up, dude. You gotta show up to class, dude. You gotta show up. It's the number one thing I tell students. You gotta show up, dude. Okay, because like integral of cosine is 1 over n sine of nx, right? And then this becomes negative 1 over n squared cosine of nx, and then this becomes what's that? 1 over n cubed? No, negative 1 over n cubed. How many people are ahead? Just 4. Here, I'm gonna just like leave this real quick, and then it's a cool question, Mistral, but why do I keep losing connection to my server, dude? This is annoying. No. Why did I put negative, Matthew? Just submit 1 for now, and then if I have time, I'll go back. I'll go to more of them. Okay, integral of cosine is sine, but then there's a 1 over n sine of nx because of this, and then integral of sine is negative cosine, but then you pull out another 1 over n, so it's negative 1 over n squared cosine of nx. Yeah, we're integrating, all good. And then integral of cosine is sine, so then you keep the negative. And then finally, we go back to another negative, so we get 1 over n to the 4th cosine of nx. Okay. And then I think how the trick works is you do like... How are they doing it? Yeah, it's this one. What's up, AD? He's a great resource. This is... Okay, cool. One sec. I gotta change my... Let me change some Twitch settings real quick, because this is dropping too many frames for me. Be back in 2 seconds. Okay, cool. I see it. Sorry, this was negative 1 over... Yeah, negative 1. And then this is finally 1 over n to the 4th cosine nx. Oh, ei theta. Yeah, I guess you could do that too. And then it's this. Why is there the... Oh, the red and the blue is positive and negative. Oh, I get it. Yeah, I can definitely help you. I'll do it. Yeah, I don't know. It should be running fine though, right? Yeah, I changed some streaming settings. Yeah, what's annoying here, and I'll just show you guys, because this is kind of like the plight of streaming. Is that we were good for the first, what was it? The first 40 minutes, and then I started getting all this. This is what doesn't make any sense to me. It's like, it's rock solid for a bit, and then just starts running into issues. And, I don't know, that's... Part of the fun in streaming is debugging, like, why did that happen? Why did I lose that? Now we're good again, but... Issue is I can't do 1080p now. It's okay, though. Yeah. Okay. So I think this is x to the cubed over n sine nx. And then it's minus, so that's plus 1 over n, so x squared over n squared cosine nx. And then it's minus x over n cubed sine nx. Yeah, maybe I should, right? Yeah. And then it's minus 1 over n to the 4th cosine nx. Okay, cool. So wait, that's all that. That's kind of a mess, dude. And then what? Finally minus this. So then minus 2x over n. And I think there was a 3 in front of all these. So this is 3. 3. 3. 3. And then this is 2x over n sine nx. And then it's minus 2 over n squared. Wow, that's a short integral. Get in it. Okay, but then what's the point of this? Is that a series? I mean, maybe we see like a pattern here, do we? Am I supposed to like reconstruct this somehow? Yeah. I don't think I see any patterns though, no, right? And this becomes like minus, but then they don't even have the same denominators. Oh no, Fourier series. Okay, I think this, here, Q's getting kind of long. This is Mistral, this is how far as I'm going to go with this one. Interesting question though, Mistral. I appreciate it, it was fun. Alright, let's see, that was Mistral. And then I'm going to test something here because I'm curious if my console now works. I'm going to mark this as done. And then that should show up now in our thread, does it? Oh, it showed up twice. Oh, I don't know why it showed up twice. Oh, you posted it, Mistral. That's what you did. Oh, okay, cool. That works too. Speaking of done, has he streamed today? Has Dawn streamed today? I don't know if Dawn streamed today. All right, let me see what we got. Colton. Let's see what you need help with here, Colton. Okay, we got the graph. This is loading. Okay. Which one shows the graph? Oh, maybe. Oh, are you just asking maybe just to graph this? How would we graph cotangent? We can do that. It's not too bad. So, the original graph of cotangent, I know tangent looks something like this. Sorry. Tangent looks like this or something, right? Or wait, opposite of adjacent. So sorry, actually it's the other way, right? It's this way. This is tangent, right? Yeah. That's tangent. But then cotangent is 1 over that. So it like shifts over by pi over 2, I believe. So I think correct me if I'm wrong. I think it's this way. Right? Because opposite of adjacent, negative. Lisa says, hey, I want to ask about a question I took today for a calc test. It was a parabola and I was asking for the inflection points, and it's a parabola. Parabolas can have inflection points, yeah. Second derivative just needs to be 0. Oh, cotangent is a person facing right. Tangent is facing left. That's a good way to think about it, actually. That's really cool. I like that. Yeah, like, so for instance, this is like a person like Just chilling. Okay, facing to the left. Cotangent's facing to the right. But also, it has its asymptote right here. Okay. So, in order to figure out where the asymptote is, right, that's... Where is it? That's this thing, right? We have to figure out where cotangent of... Where the argument of cotangent is equal to 0. 3 pi over 2. We set all this equal to 0. And then I think we also set it equal to pi. Right? Because cotangent is periodic by pi. The cube root of the cube root of the cube root of 3. Or the square root of square root of square root of square root of 3. You submit a screenshot, I'll do it. Okay, so for this occurs when, so you solve for this. 2x is equal to negative 3 pi over 2. X is equal to negative 3 pi over 4. Okay. And that makes sense, because plus something means it's a shift to the left, okay? So that tells us we're moving this thing over to the left. And that's going to be at negative 3 pi over 4, okay? That's where, like, the first asymptotic infinity happens, I guess, right? And then the other cool thing here, right, is this plus 1 tells me that it's not going to have its inflection point at y equals 0. It's going to have it up at y equals 1. Right, this is kind of like the other bit of information you get from it. Yeah. So this is at y equals 1. And then this is x is equal to negative 3 pi over 4. All right. This doesn't really do anything. We don't really care about the 1/3. What's the restrictions? Yeah, we can get to that. So you want to figure out where this thing is equal to 0, and then also where it's equal to pi. I think. Right, that's the other... It's opposite over adjacent, right? That's where it goes to negative infinity. Yeah, okay. So find out where this is equal to 0, and then you also set the argument equal to pi. So you get 2x is equal to 3/2 pi minus pi is pi over 2. So x is equal to negative pi over 2, sorry. X is equal to negative pi over 4. Oh, wow. Okay, so this actually has a really short period. That's true. If it's not 2 pi periodic, it's sine x and cosine x of a triangle, which is pi over 4, yeah. Yeah, okay, cool. I think this is right. Okay, so actually this is cool. So the other asymptote actually happens at negative pi over 4. So actually this is a really narrow cotangent. I guess so, because it has a 2 pi on it.
Nice.
All right, so let's move this over here. Okay. So then your next one is going to be at x equals negative pi over 4. And then it just keeps doing that, right? Just over and over and over. So you end up getting something that looks like this, I believe. And then this coordinate right here would be the halfway point between these two. So that's just going to be negative pi over 2. Okay? And then you just repeat. What's even the question? It was just graphing this. Just graphing cotangent. I was showing how to graph it. Here, let me move that out of the way. And let's get these two things so you guys can see it. Right, because then you have another one of these basically. You'll check Desmos? Yeah, if you want to check Desmos. Oh, we can check Desmos too. That's cool. I'm fine. I have no problem checking Desmos. Here, I just want this part. Yeah, so it's like that. Or actually, wait, sorry, I don't want this label. Get rid of this label too. Oh, shit, I fucked up. We need more gold. What's up, Poisoned? Sorry, I need to move this down. Sorry, that's what I want. This can go away. There we go. Okay. Yeah. And so forth and so forth. Yeah. So then this one would end up being, so the period looks like it's pi over 2. So then this would be x is equal to positive pi over 4.
Nice.
Yeah. It's easier if you change the powers to fractions. Then this is going to be 3 pi over 4 again. Yeah, okay, cool. Yeah, if you wanted to look at it, yeah, we could graph that. And I think we can do it right here. Actually, I think I can do it within Desmos. No. Oh, I didn't want that accidentally. Ugh, damn it. Sorry, I gotta put this on a new page. I can definitely do limits. Yeah, I can definitely help out with limits. I do a lot of limits. All right, let's see. Graphing calculator. Okay, so what was it? It was 0.5. Cosine of, I think it was 2x minus pi over 2. And it was like plus 1. Is that what it was? One sec. Oh, it was 1/3 cotangent, sorry. 2x plus 3 pi over 2. Yeah, and then the 1/3. There we go. Nice. Okay, cool. I think that looks pretty close to what we have. And then what's up, clickbait? Thanks, dude. Appreciate it. Yeah, I did some cool updates. I was vibe coding this weekend, dude. And I want to look at like x equals 1. No, sorry, y equals 1. That's what I want. Nice. Let's change the color on this. Where's like colors? Can I change the color of this? Yeah. Yes, exactly. Dissonant fonts. Yeah. No, I tell them all. Well, yeah. So YouTube is our way of like getting exposure because Twitch is absolute trash for discovery. It's so bad. But YouTube does a really good job of promoting us. So I do tell people, and that's why on the website here, when they go to when they go to like upload, it says like, you know, watch live on Twitch. Twitch is the supreme format for sure because it's horizontal. Okay, I'm just gonna get this graph just so we can see it. I'm pretty sure I had it right. How can you actually know the answer beforehand? I don't know the answer, but I can just do it, right? Okay, so then this was the... Oh, let's get rid of that. This was her graph, Colton's graph. And let's see if it matches up. I think it does. Right? The first one, yeah, has an asymptote at negative pi over 4, so that's like negative 1 almost. Yeah, which is basically what this is, right? Yeah, well, negative 0.75, yeah. Crosses at 1. Sick. Okay, cool. So again, the strat with these, and I have videos on this, but always just like set this argument to 0. Just set this equal to 0, and then set it equal to like what the periodicity is. So for tangent and cotangent, you want to set it equal to pi, because that's how often it repeats. For sine and cosine, you want to set it like equal to 0, and then set it equal to 2 pi, and then you do the points in between, like set it equal to pi, or then set it equal to... Yeah, this was just manually plotting a function, but I'm showing that there's a pretty easy way to do it if you understand how the original functions work before all the transformations. And that's really just setting the argument to 0 and then to either pi or 2 pi. And then you basically figure out what the endpoints are. Like once I set it equal to 0, I was like, okay, this is a regular cotangent function that's starting at negative 3 pi over 4. And then when I set it equal to pi, I'm like, okay, but the cotangent function is ending at x equals negative pi over 4. So now I know where it starts, I know where it finishes, and I know what it looks like in between because I know what cotangent looks like. For sine and cosine, you figure out like where it's 0, where it's equal to 2 pi, and then you know that halfway in between those two x values is like something significant, and then you know halfway in between those halfways, which I call the quarter points, are also significant things. And it's a much easier way to graph than trying to manually do this phase shift nonsense on your own. You don't want to do this. Like, this phase shift with this, it just doesn't work. The best way is set whatever the argument is to 0, pi, 2 pi, and then everything else is golden. Yeah, you just sketch with critical points. Yeah. All the probability theorem from axioms to Markov chains. Wow, I don't really know much about Markov chains, but if you join us on Twitch, I do have a really awesome collection of math streamers that do help out with that type of stuff. Here, that's what there. Okay, anyways, good question there, Colton. I appreciate it. It was cool. Oh, you know, I can actually do that on YouTube as well. I forgot. I do have access to that. Where is that? There we go. Okay, sick. Okay, so now I'm going to go through to my thing. I'm just going to mark that as done. And the awesome thing is, now if I look at it, I can just dump this in for her. So yeah, if you submit a question, it automatically gets posted to our Discord here. And then I will post the solution that I did for it here as well. So join our Discord and you can see your question getting solved. You can download the solution for it. You can also see everybody else's questions. There are a lot of really other fun ones that get asked throughout the streams. So if you guys want to learn. Thank you. You taught me in like 5 minutes. You're great. Oh, I appreciate that, Colton. Thanks for hanging around.
Good job.
Yeah, I have a video on this as well, Colton, if you want a little bit of help. Just to review it. Where is it? Not my TikTok. I have it on YouTube. I'll send you the link right here. But it's one of my more popular videos. You go to search here. And it's graphing sinusoidals, I think is what it was. Yeah, how to graph sinusoidals. Yeah, here we go. Here's the complete guide one. This is like the full video. What? I get ads now on my own YouTube. That's what I get for being monetized. But yeah, this right here has kind of the whole trick I use with the points and stuff. Sorry, here, I'll send this to you as well. Where's my chat? There you go. Check that out. Cool. Great question. I appreciate you asking. Thanks for hanging around. All right. You don't want any more fruit? Fruit's great, dude. I love fruit. Fruit slaps. I had a clementine at like 4 o'clock this morning. It's delicious. All right, next question coming up is Jake. All right, so let's see. Jake, what did you submit to me? Ooh, nice. Which one do you want me to answer, Jake? 13 or 14? Pick the harder one. Or the one you need most help with. If I have time, I'll do the second one later. This is physics. Both, of course. I don't really have time to do both, though. The queue's already at 8 questions. I'm going to see if Jake answers real quick. Otherwise, I'm just going to pick one. Oh, I'm sure Steve Jobs did. Yeah, rest in peace, dude. Okay, it's a fun problem, isn't it, clickbait? All right, I'm just going to do 13. I'm going to do this one. The physics with a professor who likes to grade in a bell curve. Dude, that's, yeah, I don't do that. That's terrible. Nobody should do that. Or why that's not copy? No, that he made Apple products too expensive for me. He did change the world, though. Man. Wow, famished! Buy myself a cup of coffee. Thanks for the 50 bits, dude. That's sick. Thank you, famished. I will buy myself a... Literally the only thing that helps my ADHD. Yeah, what's your favorite type? I love Americanos. I'm a big Americano guy. Okay, a baton. Well, that's not a baton. That's a circle. Do you teach grad physics courses? Not so much. I mean, I can try, but those tend to hurt me. Gold speaking Spanish. Americano? That's Italian. Ma io posso parlare italiano anch'io. All right, 0.36 meters long and masses at each end. Okay, cool. All right, so we got mass. Got that mass. Oh, is it Spanish? Americano? I think that's... What would be the Spanish versus the Italian way to say that? It's kind of the same. Ooh, Colombian coffee. Yeah, nice. I don't think I've had Vienna coffee. Okay, this is 0.48 kilograms. Assume the rod is massless. The rod is first rotated about its midpoint. It is then rotated about one of its ends, and in both cases uniformly accelerates from 0 rads to 2.4. Okay, cool. So automatically, we know alpha. Here, this is angular acceleration, which is equal to change in omega over change in t. I just know I'm going to need this. And so this is going to be 2.4 minus 0 over 3.6, which is the same thing as 2/3. Right? 1/2s, yeah. Okay, so this is radians per second squared. I just know we're going to need it. Portuguese, you don't call it Americano? What is it? Americano or something? Bom dia. Obrigado. Oh, are we at 2K yet? We're at 1998. You know, we're also... I think we're very close to 9K on YouTube as well. That's Brazilian. Okay. Abestando. Okay. Find the torque exerted by the swirler when is... Okay, this is cool. Okay. So, here's the key thing. Torque is equal to I times alpha. Okay? So, when rotated about the center... I is equal to the sum of mr squared, which in this case is 0.48, this mass, located at a distance 0.18 meters. So we're going to say 0.48, 0.18 squared, plus this one over here, which is the same thing. So plus 0.48 times 0.18 squared. I dated a girl from Colombia for 6 months, yeah. And she didn't speak any English, so I had to kind of really learn Spanish. Yo tuve una novia de Medellín, no, de Cali, una otra ciudad, para 6 meses. Yo pienso que está correcto. Yeah. Alright, let me pull up the calculator real quick. I was in Medellin for a while, but actually I remembered I was in Cali when I visited her. Cali. What's the question looking like? We're doing a little bit of torque. Okay, so we do that, then we do times 2. So that's 0.031. So then torque is equal to just I times alpha. So that's going to be 0.031 times 2/3. What is that going to be? She had a nice shake. She was a very kind person. Unfortunately, there's a lot of visa issues between the US and Colombia, so it was very difficult to actually see that moving anywhere forward. It's hard to get visas for Colombians. Unless I like propose to her, which I wasn't about to do. I mean, that's kind of a lot. Yes, poisoned. Okay, great. Okay, that's Newton meters. Cool. Okay. Okay, rotate about the end. Okay. Okay, when rotated about the end. Nice. This is cool. So when you're rotated about the end, now this mass doesn't count for moment of inertia because its radius from the rotation axis is 0. So now I is just equal to, again, mr squared for like the far end one. This is, yeah. And so that's going to be 0.48 times 0.36 squared. It's going to be 0.0622. Notice how this is actually more inertia, right, than the other one, even though the other one had 2 masses. Cool, and that's going to be 0.0414. Uh, 0.042 newton meters. Oh, wow, Miss Venezuela. Is torsion the same as in group theory? If X and G is torsion... I don't know about torsion. Clickbait says, I was dating a Colombian girl for like a year and it was about the same. I was too lazy to learn the Spanish, though. No, dude. Also, you spelled Colombian wrong, dude. If you spell it with a U, dude... They're not going to be happy, dude. You have to... Colombian, not Colombian. You can't say U. They're going to get mad if they see the U. I'm using a software called Group World. Okay, cool. All right, this is a good question. Thank you for this one. Appreciate it, Jake.
Well done.
Exactly, Poison. Colombia's not Colombia. They'll get mad. They'll get so mad. Don't ask me how I know. Okay, nice. Okay, so that question just went into our Discord. So this is the cool thing. Look, I just hit a button, and then this comes up. It says, like, new post. I click on it, and then... wait, where is it? Where's the question? It just got posted. There no, that's Colton's. Wait, one new post. There we go. That's Jake's. Okay, cool. And then I'll just dump the solution in. So happy about this. And actually, I am going to mark, I think, on here, on Mistrals. I'm going to give this one the tag. I'm also going to edit the tags on this one. I'm going to say unsolved because we didn't exactly do all of it. I'm going to say for pure math gods. So if you're a math genius in my channel, if you're either Don, Eric, Sidud, or Penn Center, that's kind of a fun one if you guys want to. I mean, do during your streams. I know a lot of people on Twitch are sometimes kind of have like their hands open. They're like, wait, what am I supposed to do? Like, I don't have any questions. And I see this as maybe a way to just funnel in tons of questions from live viewers like yourself. And then it's good to have something just like to seed the pot. Like, yeah, we already have 8 questions in the queue right now. But let's keep rolling. So next one is from Daniel Barber. What's up, Daniel? Ooh. What's this? The fuck is this? Got more math. She doesn't need a visa. She does if she doesn't have verifiable income, which I'll let you read between the lines for why that was. Sometimes I think physics is not science at all. It's just an easier math. Yes and no. Because physics does have some unique rules that affect the math. Like, for instance, just the most basic of cases, right? We know maximum height occurs when, like, velocity in the y direction is 0. And then that's why you can say that, which I guess that also makes sense for math. The derivative is 0. There's just other things. There are other, like, unique things. Like, for instance, the sum of the forces is equal to the mass times acceleration. I don't think that's, like, intuitively baked into math, right? But you can set up differential equations and stuff that represent those things. And you can solve for real world things. It's really good. It's cool. Okay, this one is kind of a pain. I'm tempted to do this in spherical coordinates. No, it's okay. You're right. Medellin, that's correct. With the double L's, yeah. Why do physicists have more riz than mathematicians? I don't know. Is that like a trick question? I don't think physicists really have a lot of riz. I mean, I'm not your stereotypical physicist. Don't do spherical, Poison says. But I see this, and I want this to be like r squared, right? Do cylindrical, he says. Now, Poison, are you trolling me? Or should I actually do cylindrical here? Daniel says it's in spherical. So I'm tempted to do it in spherical, which is okay. Yeah. Okay, but I gotta go remember. Okay, first of all, and this is a math class, right? So we have to do math spherical. How many people are ahead? I think like 7. So if you ever want to look at, so if you go to the website here and you click on live queue, you can see what the queue is at, and you can also like click on people's questions if you want to see like exactly what we're working on. But I need spherical coordinates. Okay. Spherical coordinates. And I think this is the math way, right? You are correct, Poisoned. You are correct. You are correct. Now, is this the math form of spherical coordinates? Or I guess it doesn't matter, right? As long as we're consistent. There's around 6 to 7 in the queue. No. No, dude. No. There's 8. There's not 6 to 7. There are 8. Okay. All right. Let me just like start writing some stuff because I think this might help. So yeah, instead of like dz, dy, dx, I'm gonna do is it sorry, what is dv? What is dv in spherical? There you go. It's yeah, okay, this is what I want. Oh, but that's hyperphysics. Oh, we gotta be careful because they switch their phi's and their thetas. Wait, no, actually that's the same. Right, phi's from the z-axis. No, see, here phi's from the x-axis. No. Physics and math have different conventions for spherical. It's super annoying. I think this is right. Yeah. Yeah, if you want to donate $5, you can totally get ahead of the queue. Yeah, sure. Did you donate $5 when you gave me those bits? Or that was famished? Okay. I think this is what I want. Donations are always welcome because they help me fund my nonprofit. Send me gold. Okay. Okay. I'm going to replace this with dv, which is equal to rho squared sine phi d rho d phi d theta, right? And then let's see if we can like simplify some of these bounds, right? So x squared plus y squared, that's the same thing as rho squared sine squared phi, and then that's cosine squared theta plus sine squared theta, right? So that's nice. That goes away. Okay. Okay. And then 16 minus x squared. It's not really the nicest thing, is it? This is where I start thinking I should draw this. Yeah, I think I want to draw this. Because then I think I'll see it easier with what's happening. It's hard for me to like actually just start like converting this like out of the blue. Okay. My trick for doing these is I always look the furthest out and then like work my way in. Okay. So I know that I'm going to be integrating from 0 to 4 in terms of dx. Okay. So if this is x, this is y, this is z. That means we're going from here to here, right? I need to integrate that way. Okay. And as I do that, so as I start like building my slices this way, okay? My y needs to go from 0. So here, let me put like some colors on this. I think that'll probably make some sense. Let's do that. Let's say this. Let's say this right here is 0 to 4. So that's gonna be 0 to 4. But then as I graph in terms of y, I want to go from 0 to 16 minus x squared. Okay, so in terms of y, that means I'm going to restrict myself from here to 16 minus x squared. Square root of 16 minus x squared. Which this, so we say like y is equal to the square root of 16 minus x squared. That's the same thing as x squared plus y squared is equal to 16. So that's a circle with radius 4. I was starting to convert them, but then like this one's gonna be messy, bro. I don't really want to do this one. Right, 16 minus x squared, but then it's like, do you see this? This like sucks. I don't think I want to do that. I mean, maybe I do. I just like to see it first. Because this is cool. Because this is a circle of radius 4. Which then I know, oh, this is very cool. Because watch. That means we're just going to have this. Right? Okay, and then as I do that, what happens to z? Okay, this is where things get a little tricky. So, z is going to go from the radius it is in the xy plane up to 32 minus the radius in the xy plane. Oh, this is why cylindrical actually would make more sense. Yeah, wait, Daniel, can I do this in cylindrical? I think Poison was right in the first stop to do this. I don't think I want to do. I don't think I want to do. Poison says do it in spherical. It is way easier. Ooh, PDE's not so much. DiffEq, yes. Partial, no. He says it's way easier. I'm confused why it's way easier. Okay. All right, because then in terms of DZ, this looks gross. I agree. It does look pretty gross. Okay, one sec. As we go this way, I integrate from here to here, and as I do that, I'm going to integrate from the square root of x squared over y squared. Okay, so that's... Oof. Oh, as a 9th grader? Yeah, no, you haven't yet. This is a calculus thing. Upper calculus. This is vector calculus almost, probably. Or, no, not vector. Yeah, maybe it is vector. Maybe calc 2. Okay. Yeah. I know it's this, at least for the base. How it goes in Z is actually kind of weird. It's like the square root of 32 minus r squared. So, I always like to think of initial conditions. So, when x and y are 0, it's starting here, and it's going up to the square root of 32. Right? Let me just see if I can kind of picture this. It's going from here up to here. Right? And then when x squared plus y squared... Well, x squared plus y squared at the most can equal 16. Right? So that's on the border here. That's where x squared plus y squared is equal to 16. And 32 minus 16... Uh-huh. So in that case, it goes from 16... Sorry, yeah, no, sorry. It goes from the square root of 16 to the square root of 16, which is 0. Oh, okay, cool. So I think it does this. I think it's kind of like this. I think it's like this. Yeah? Like, if I hold... Right, if I hold y equal to 0, then in the xz plane, that's z goes from x... Wait, y equals 0, that goes from z equals x to z equals the square root of 32 minus x squared. Okay. Complex analysis, yeah. Okay. Oh, x squared plus y squared is that. So, I think I kind of have it drawn out, but it is kind of weird. Okay, so square root of x squared plus y squared is going to equal to rho sine phi, okay? And then square root of 32 minus x squared minus y squared is the same thing as minus x squared plus y squared. This is the same thing as this, right? You're typing a lot out, poisoned. Yeah. All right. Square root of 32 minus rho squared sine squared phi. Yeah. And 16 minus x squared. Ugh. One sec. Let me see what Poison's saying. Okay. It is hard, bro. No, it definitely is hard. In 2 dimensions, it's okay. In 3 dimensions, I start to get a little mind fucked. Like, I'm pretty good at... I know what the 2D cross-section is. I'm like, cool. That's going to go from... in terms of spherical coordinates, right? That's going to go from 0 to pi over 2 in terms of theta. Right? I already know that, right? So theta goes from 0 to pi over 2. And then phi, I'm pretty... phi is a little bit weird. Why'd you get into to physics? I just liked it the most in high school. I like the problem-solving abilities of it. It's really fun. And then R... Get off live. What, you're on winter break? This is not winter break. This is the heat of exams for kids right now. Let me see. Oh, we still got 8 questions. Big rat. Okay, we're okay. Not too bad. Not so bad. Oh, yeah, no, that... Dude, a bad physics teacher will ruin it for you. Yeah, 100%. Okay, and then I agree that, like, R goes from 0 to 4. I think where I'm having the problem here is how does phi relate? This last part here is messing with me. X equals 0. Yeah, Diffie Q. No, I haven't tried cylindrical, and you actually are you're the second person to suggest that, and I kind of agree I want to do cylindrical, because I think it would be a lot easier to just say this is going from R to 32 minus R, right? I think I am going to do that. I am going to do this in... Sorry. Yeah, I'm going to do this in cylindrical. I don't really like it in spherical. It looks like it kind of sucks, honestly. Okay. Let's do it in spherical. Let's do it in cylindrical. Just because I understand that, like, the base here is really easy. This is a quarter of a circle in the first quadrant. And then the z, if I can now define in cylindrical that x squared plus y squared is equal to r, this becomes a lot easier to deal with. Yeah. Because then r is measured from the z-axis. Yeah, let's do it. One sec. Usually you set it up, then convert it to spherical. Yeah. I just think this is easier because now my bounds just go from z equals r to 32 minus r squared, right? Let's just do it that way. Yeah, because that I understand. I don't understand how that works, how this works in spherical. Yeah, okay. X squared plus y squared is equal to r squared. So I was just contemplating life. I really was. So square root of x squared plus y squared is just equal to r. And then the square root of 32 minus x squared plus y squared, that's just equal to the square root of 32 minus r squared. Okay. So now, and we don't need fucking phi, dude. Fuck phi. Great. So now, yeah, r goes from 0 to 4. Theta goes from 0 to pi over 2. And then z goes from r to square root of 32 minus r squared. I like this. This is I don't know. To me, this is cleaner to look at. Which I think it's a cone, right? I think it becomes a cone because look, if you were to hold, for instance, hold y equal to 0, right? Then this goes, in terms of z, goes from y equals x, sorry, from z equals x up to z equals the square root of 32 minus x. (32 minus x squared, sorry. Yeah, so I think it's like a cone. Yeah. This part, though, was messing with me, though. Because also, like, I don't know how to do the phi then. How does the phi work? Okay. So let's set up our integrals then. Okay, that's 0 to pi over 2. Like, d theta, right? And then that's 0 to 4 dr. And then the dz is like messy. It's okay. You're remembering it now with us. All right. And then the dz goes from r to the square root of 32 minus r. And then in this case, x equals r cosine theta. Y equals r sine theta, right? And then z is just z. So xy becomes r squared sine theta cosine theta. And then I think when you do this integral, it's r dr, right? This is now like dv. Yeah, 32 minus r squared. Thank you, Joseph. Yeah. Yeah, I think this is now dv, right? Okay, cool. Jacobian type shit. Yes, it is a Jacobian. That is where that comes from. Okay, cool. R cubed sine theta cosine theta dz dr d theta. What is the ticker shout out? Oh, I changed the ticker on the stream for you. You can tell me if you want to change it to something else. It only really shows on the vertical too. The horizontal ticker is kind of broken right now. Okay. 3 Stream Street. Okay. It is the transformation between like Cartesian and like whatever. I'm glitching. What am I glitching? I don't think I'm glitching. Looks fine to me. Okay. This integral is going to be r to the 4th. Yo, what's up, H? I do need water. Okay. All right. This integral in terms of dz. So that's just going to pull out a z, but then this is going to go in there. Oh, this is just ugly. Oh, man. Okay. Maybe this would have been prettier in spherical, but I at least understand it in cylindrical. Now this is r to the 3rd sine theta cosine theta, and then it's going to be square root of 32 minus r squared minus just r, right? Okay. And then this is dr d theta. Okay. Now this integral sucks. If I get time to it, Samsung, I already have a pretty long queue of people so far. All right, let's see. You know, I'm gonna take this stuff out, and because I can integrate this. This is the only stuff with theta, right? So actually, let's reverse the order of integration. Let me do this one first. Let's do the 0 to 4 last. Yeah, I'm gonna reverse the order here, which you can. This is okay because they're just numbers. By Fubini's theorem, yes, Fubini says if it doesn't depend on it, you can just move it. Well, the nice thing with this is sine theta cosine theta, I believe, is the same thing as is that cosine 2 theta, or is that sine 2 theta? Where's that identity? Oh, it's 1/2. Or just use a beta function. No. There we go. It's 1/2 sine 2 theta. This is the one I wanted. This is why your trig identities are important, guys. Okay. Okay. So sine theta cosine theta is equal to 1/2 sine 2 theta. Good to know. Okay. This is cool. And that's all this hot garbage. F needs to be sigma infinite. Okay, cool. Yes. Okay. Oh, and then integrating sine of 2 theta. One sec. If you integrate sine 2 theta, that becomes negative 1/2 cosine 2 theta. And if that's evaluated from 0 to pi over 2, that's the same thing as negative 1/2 cosine of pi minus minus. So then that's plus 1/2 cosine of 0. Right? So this is negative 1. Well, that's 1. Isn't that just 0 then? Wait. Integral of sine 2 theta is, yeah, negative cosine 2 theta. I am bringing the 1/2 out. Well, there's another 1/2 on it. Oh, it's 1. It's 1 plus 1. Sorry, it's 2. Oh, it's just equal to 1. Oh. Oh, yeah, sorry. Yeah, sorry. This here is -1. So you get 1/2 plus 1/2. It's equal to 1. Okay, cool. So this whole thing just becomes 1. Yeah, this is a useful one to know. It just equals 1. Okay. All right. So now we're left with the final boss, 0 to 4 of r to the third square root of 32 minus r squared minus r dr. I forgot the d theta. Okay. You're right. I did forget the d theta. Okay, my bad. All that work for 1. Love the analysis, right? Yeah, okay, cool. All right, this is it. This is all we got. We just got this. I'm going to do these integrals independently. So 0 to 4 r to the third square root of 32 minus r squared dr minus integral from 0 to 4 of r to the fourth dr. This is easy, right? This is r to the fifth over 5 from 0 to 4, right? This one is nasty. Oh, man. I wish I could do u sub here. I can't. Because the derivative of this thing doesn't show up somewhere else. Do I have to do integration by parts for this? Or, wait, I think, let me think how I want to do this. No. Yeah, submit a question. Submit a screenshot, I'll do it. How do we do this? How do I do this integral? Office, the website there, actualofficehours.com. U sub under the square root. Okay. Do I have to do like trig sub though? Because if I say u is equal to 32 minus r squared, du is equal to 2r. It works nicely, he says. Okay, fine. All right. I'm going to trust you on this. Are you saying this is u? So then du is equal to negative 2r. Okay. Okay, let's check it out. Let's see what he says. Oh, okay. So, 2r dr. Okay, so dr is equal to negative 1/2 du times r. Or negative 1 over 2r, sorry. Du, right? Yeah. Okay. Oh, okay. And then, okay, one sec. I think I'm starting to see this. All right. Don't murder me. I'm not gonna write my bounds yet. Yeah, exactly. Okay. And then, yeah, okay, so then r squared. Yeah, so from this, r squared equals u, equals 32 minus u. Oh, wow. Okay, so r to the third equals 32 minus u to the 3/2. Right? Is that right? Yeah. You don't even need to do this. Okay, well, let's just see it. Okay, sorry. But this is r cubed, though. That's the issue, right? So this is r cubed, and then I have the square root of u, and then I have minus 1 over 2r du. Oh, I see. You are right. Okay. This cancels with this. Now I have r squared. Oh, beautiful. Beautiful. Yeah. What happens if you do trig sub? Scary things happen.
Oh, no.
No. Mass speedy. Did I get it? So you can always check on the queue. Midget mucker. Okay. That's an inch. You submitted it 4 times, but yes. I did get it, Mass Speedy. If your name is Midget Mucker, it's there. Okay. So this is integral. I see. This is cool. This is 32 minus u times this times u to the 1/2, right? Dun, 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 dun. Okay. U to the 1/2. Oh, I see. Very cool. So then this is 32 u to the 1/2 minus u to the 3/2. Yeah. Okay. Vesper? Yes, I can do Vesper and stuff. Yeah. Okay. So then this is 32... man, times 2/3 u to the 3/2 minus 2/5 u to the 5/2. Don't lose the 1/2 factor. Where did I lose the 1/2 factor? Oh, yeah, okay, sorry. And then, yeah. Negative 1/2. Sorry. Yeah, there you go. Right, good. Yeah, from this. Thank you. Gotta keep track of everything. Okay, fuck. And then u is equal to 32 minus r squared. So this is negative 1/2. We're gonna say 64 over 3. And then this is 32 minus r squared. To the 3/2. Minus 2/5. 32 minus r squared. Dude, this is ugly as fuck. No. Dude, why? I think Poison was right. If I just, like, learned how to do it in spherical, it probably would have been as nice. Yeah, so I never change the bounds because I like to just keep things the original bounds. So I wait until I substitute back in for what u was, and then we're cool, is what I say. I guess it doesn't really matter that much, right? Yeah. Either u goes from like 0 to 16 or 32 minus r squared goes from whatever, 32 to minus 16 or something. Does it do the womp womp? I don't think so. Okay. Cool. Now it's just a mess of algebra. Such a mess. All right. Let me get a calculator. What's up, Daniel? Yeah, no, this is kind of a mess for this one. Wait, and let me make sure we did everything right. What did I miss? Oh, that was just a factor of 1, right? Okay. So we have, and then it's minus this, which I can figure that out, right? And it's all this minus. Okay, and then it's minus r to the 5th over 5, so minus 4 to the 5th over 5. Okay, cool. Yeah. You know what I'm gonna do? I'm just gonna define this as a function in my calculator, and then I'm gonna put in 4 and I'm gonna put in 0. So I'm gonna say 64 over 3. Where do you sign up? You just submit your screenshot, and I'll do it here on the stream for you live. Oh, the paid one? Oh, I don't really do much paid tutoring anymore because I'm kind of like busy with everything else. I just do free tutoring now. Also, yeah, my paid tutoring is really expensive. I don't really wish people to pay me that. It's way too much money. Okay, there we go. Okay, so let's set 0 equal to x. Or actually, no, let's set 4 equal to x, right? Cool. Let's do this. And then we're going to do and then we're going to set 0. Sorry. We're going to say 0 is equal to x. And then I'm going to do it again. And so then I'm going to say the 4, 1 minus the 0, 1. Cool. Times negative 0.5 is that. And then minus 4 to the 5th over 5. So wait, this whole thing here I get is 294.48. And then minus 4 to the 5th over 5. 89.68 is my final answer. Do we know if that's right or not? UC Berkeley or MIT for biomedical engineering? Ooh, depends if you're cool with the cold, Mochi. If you like the weather, I wouldn't go to MIT. Their winters are pretty brutal. MIT is definitely the better school, technically. But I would say visit both and see what you vibe with more. You know, I really liked Los Angeles, so that's why I went to UCLA over some other schools I got accepted to. UCLA is great. Yeah, I went to UCLA. Okay, 89.68. That's what I got. And I think that's pretty correct. I don't think we're missing anything else, are we? Okay, cool. All right, there you go.
Well done!
I might be missing like a factor of 1/2 somewhere. I don't think I am. Oh, very good question. Yeah, here I'll answer that for sure for you right away. Daniel, let me upload this question for you though first. So mark as done. So your question will now show up in our Discord. There it is, Daniel. And then I'm gonna put this in here for you. And then I will say, could probably be done nicer with spherical. I have a hard time visualizing spherical. I really do. I can't send it to you. You can join my Discord though. We have a really big Discord that I post all the solutions in. Okay, cool. Can I do limit proofs? Let me answer Daniel's question. So Daniel said, how can I be a math tutor? Most online services make me pay for leads. So you should never be like paying for leads until you get the lead, right? I'm okay with like whatever service is taking a cut out of like what you charge. That's totally fine. The one I used to tutor when I first started doing this in grad school is Wizant. I think, yeah. This is my profile. But start on something like this. Wizant's a great profile to get started on. You have to charge a lot less starting out. I charged like $30 an hour when I first started tutoring. And then I started getting booked a lot. And you start building up, you know, reviews. You start getting kind of word of mouth. People write really nice reviews about you as well. I don't know, like some people say like, what, I was life-changing or some shit. I don't know, that's great. Anyways, yeah. And then you end up raising your rate more and more, and then it's justified because you're a better tutor at that point as well. So, yeah, I highly recommend Wizant, Daniel, if you want to. That's how I got started with tutoring. And then from that, you can start trying to advertise locally. I don't know where you live. I live in Los Angeles, so it's a very dense city. Also, a lot of people with disposable income, and I don't know, they like just don't want to deal with their kids. so they hire me instead. So, you know, kind of goes both ways. What's the Discord? The same link you used, Mass Speedy, to upload. There's also a link here that says join our Discord. Also, I'm pretty sure when you upload a photo, it literally says, hey, join our Discord. Yeah. Okay, cool. All right. Let's do the next one from Dawn. And actually, I see we have a lot of questions. I'll extend the tutoring time because I actually don't have to tutor anyone else today. I had a couple students that are out of town, so I don't have to teach them. So here, I'll extend today's session out another hour. Screw it. That'll put more time on the clock for you guys. There you go. Another hour. All right. Let's see. Dawn. Very nice guy, Gio. God bless. Bless you too, Dawn. Or, sorry, Speedy. Okay, this one. Dawn has a question with inequalities. This is fun. Dun. Here, I'll do a couple of these because they're pretty fun. Fun questions. Dun, dun, dun. Okay, let's see. Oh, thank you, Moink. Appreciate you, dude. Thanks for the kind words, man. You're a fan? Appreciate it. Wow, okay, this is kind of a pain. Okay, whenever you get stuff like this, what you want to do is you want to pretend that you're solving this for 0. So pretend you're solving for 0, and then we're going to find what are called, like, critical points, and then we're going to look at boundaries. Okay, so the first thing I notice is I can pull a 12 out of everything here. All right, so I can say this is 12. I'm just going to divide both sides by 12, actually. Fuck that. Yeah, just divide everything by 12. Yes, right, factor of 12. So this becomes x squared plus 2x minus 8 is less than or equal to 0. This has factors of 2 and minus... minus 2 and 4, right? So you end up getting x minus 2, x plus 4. Less than or equal to 0. When you get to my question, I posted the way I am. Okay. I don't know what that means. Oh, the way I'm supposed to get the questions done. Weird way of doing it. You'll probably see. Okay, that's fine. All right, so this tells me that these are the points I'm kind of questioning. So minus 2 and... So we want to check minus 2 and... Sorry, plus 2 and minus 4. Because that's what causes each of these things to equal to 0. Okay. So let's draw something. Let's say this is like 0, right? So 1, 2. This is going to be a solid line, right? Because it's equal to. And then minus 4, 1, 2, 3, 4. This is also solid. Okay. So now we have 3 regions we need to check. I need to check here. I need to check here. And I need to check here. So I'm going to say check between. So if we plug in, for instance, x equals 0, then what you get is you get negative 2 times positive 4. That's negative 8. And is negative 8 less than or equal to 0? Yes. So that tells me that this region is okay. So we can then put a solid line between this. And then we need to check here and check here. All right, night poison. We can check x equals negative 5. So when that happens, that becomes negative 7 times negative 1. So that becomes 1. Is 1 less than or equal to 0? Nope. So it's not here. And then I know it's not going to be here either. I just know from experience. Right? But if you wanted to be, you could check x equals 3. 3 minus 2 is 1, and that also gets you 7. And 7 is not less than 0. So there you go. That's that one. This one, I guess, man, what do you do here? I think you have to, like, multiply through by 12. Right? Because that's, like, the common factor, I guess. So, multiply by 12. So you get 4x squared plus 3x is less than, and then I'll move this over and say minus 1 is less than 0. Okay, this is another one that's kind of a pain in the ass to do, but it's okay. So what multiplies to negative 4 but adds up to 3? So that's negative 1 and positive 4. So 4x squared minus x plus 4x minus 1 less than 0. Okay, now you can group this. So this is 4x, x minus 1 plus 4x minus 1. So that becomes 4x plus 4, x minus 1 less than 0. So now we need to check. So you set this equal to 0, and you get x equals minus 1, and here you get x equals 1. So check between negative 1 and 1. So again, let's do some stuff, right? 0. This is going to be an open circle. This is going to be an open circle. Because it's less than. And then just check 0. So if I check 0, I get wait. Yeah, I get is 4. Wait, so that's 4 times minus 1, negative 4. Is negative 4 less than 0? Yes. Okay, cool. Good. Moink says, how do I get the 4 in the second part? From here. So when I factor this out, Moink. Oh, it's not 4. I get minus 4. So when I factor this out, this is what I get from my factors. And I want to set this equal to 0. And that happens when x is equal to 2. No, in the second question. Oh, sorry, from here. How did I get the 4? Oh, so I multiplied everything by 12. So I multiply by 12. 12 divided by 3 is 4. 12 divided by 4 is 3. 12 times 12 is 1. So that gets me to here, right? And then from here, this is factoring by grouping. And so what I do is I do this. Well, let me get a different color, sorry. I do this and this multiplied by each other, which is negative 4. And the factors of that add up to 3 is 1 and negative 4. Right? 1 times negative 4 equals negative 4. 1. It's negative 1 and 4. Yeah. Because negative 1 times 4 is negative 4. Negative 1 plus 4 is 3. And then instead of writing 3x, he says my answer isn't right. All right, we'll see. Instead of writing 3x, I write this as negative x plus 4x. And then I can group this. Oh, I see. Yep, thank you. It is not right. This is not right. Sorry. This is x, 4x minus 1. Thank you. X squared minus... Yeah, there we go. Okay, cool. Close. I was close. I make mistakes too. There we go. Okay, that's better. Okay. So now it's x plus 1, 4x minus 1. Thank you. Okay, cool. That's technically correct. All right, let's fix that. Good point. Okay, so x is equal to negative 1, or x is equal to 1/4. Yeah? We good now? Okay, so check between negative 1 and 1/4. I'm still going to check 0. Oh, no. All right, so that's 0. This is 1/4. It's like right here. right, plug in 0. I get -1. Sorry, I get -1. And that's true. Okay, so it's the same thing. So it's still good. So there we go. Cool.
Good job.
Nice. Okay. I will do... Inequalities are always fun. They are kind of fun, Steve Curry, right? Yeah. I'm curious about these two. This is actually kind of fun. Yeah, let's keep the fun going. And then I'm just going to do these two real quick. Okay, so this tells me right away that I have roots at -3 and -1, right? So these are the roots. So I have to make this like x plus 3, x plus 1. And then it's going to be something with zeros in it, okay? Right? And if I want it to happen in between, right? You check a number in between this. So like check -2. And then you see what it needs to be, right? So if I have -2, I have -2 plus 3. That's 1. And then -2 plus 1 is -1. So that's 1 times -1, which is -1. So that tells me in order for this to be true in between these two numbers, I need this to be a less than. So that's x plus 3, x plus 1 is less than 0. And then you can factor this out, right? So you can say x squared plus 4x plus 3 is less than 0. Right. And then for this one, this is roots at -1 and 9. Which channel? It's called homework help. So this is x plus 1, x minus 9. And then like something 0. And then I need it to be outside. So I'm going to check 0. Any tips on complicated limits? Limits with strings. What do you mean limits with strings? Like calculus limits with strings? Okay, so that gets me 0 plus 1 times 0 minus 9. And that's equal to -9. And I need that to not be true, right? Because I don't want to do the in-between space. So I'm going to say is greater than or equal to 0. Great, okay. So then your solution is, this is x squared minus 8x minus 9 is greater than or equal to 0. Cool, good question.
Good job.
Bing bong. Well done. Well done.
That was Dawn's. So let's mark that as done. Okay, and then it should come up here in the thread. So this is the channel, by the way. It's this one. So there's Dawn's. We'll just drag it in. Okay, Grainal Beads 69x. You have such a unique username. Why is it greater than 0? Oh, and sorry, it's not greater than or equal to. I fucked up. It's just greater than. Sorry, I screwed up. Yeah. Sorry, let me fix that. Yes. Yeah, no. So, look, here's what happens, right? I need this region here not to work, right? And that region, for instance, includes x equals to 0. So if I plug in 0 into here, I get 0 plus 1, 0 minus 9, and that gives me -9. And I need that statement here, whatever this is, where this is less than, greater than, whatever the fuck, I need that to be false. Oh, it never. Oh, interesting. So yeah, we're Cosmolano. We're on the beta for Twitch horizontal and vertical. Let me know if it won't load horizontal ever. Yeah. Yeah, the same. Yeah, you want it to be in the same domain. So you want it to not be here. So that's why I make this greater than. Cool. Nice. Okay, great. Yeah. Yeah, it's not greater than or equal to. Okay, cool. Great. Yeah, I hope our stream's working. Actually, let me check that. Sorry, I haven't checked Twitch in a bit. Let me check on our stream manager. What we're doing. Says unstable. Love that. Love that it says I'm unstable, dude. What? If I click vertical, does it show up? Yeah, no, vertical works. Yeah, there you go. That's actually really cool. Yeah, they have a vertical and a horizontal version now. Nice. I don't know why it says I'm unstable. Oh, average bitrate is too high. Oh, well, yeah, duh. That's because I'm streaming to 2 different sources now. Yeah. Okay, cool. Where do I send questions? To this website. What is it? At www.actualofficehours.com. Just submit your question. We'll go through it. Let me pull up the next one. It's from Free Fire. And then Midget, I'm gonna make... I think you uploaded 4 different times, so let me just fix that. I'm gonna clear 8. Clear 8 again. Clear 8 again one more time. Nice. Okay. Now it's okay. All right. Let me pull up. All right, Free Fire. Dun, 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 dun. Okay, let G be a circle of radius r is greater than 0. Let G1, G2 be n circles of equal radius. Suppose that each of the n circles touches the circle G externally. Oh, Jesus. Okay. Why are we back to 1998? What's the 1998? Oh, you mean in terms of followers? Oh. I don't know. Did we gain more? I don't think we gained any more followers today, did we? We also, like, gain and lose ones. Do I have to skip questions? Yes. I definitely have to skip questions sometimes. This is one I probably have to skip. Just because I have no clue how to do this. Yeah. Yeah, I watched. Yeah. One man enters, one man leaves. What the fuck? Okay. Yeah, no. I don't know how to do this. But this is a great example, because what I'm gonna do is I'm gonna send this to our Discord as kind of a what do I call it? Like a one for the super math people to try to solve. I have my PhD in physics. This is a little bit up there with things. So I'm gonna post one. And so now that's gonna come in on our Discord, and I'll show you. This is actually really cool. I coded this all this weekend. So now if we go to new posts, there's yours, Free Fire, and it has the tag office. Oh, it should have the tag. Oh, I need to put it on manually. Yeah, sorry. This one here. I'm gonna put this one as unsolved for the pure math gods. So here, I'm gonna say math geniuses if they want to take a look at that one. It's just kind of a fun one for them. Cool. Yeah. Yeah, that question gave me PTSD and nostalgia at the same time. Yeah, exactly. Yeah, I just don't understand that. It's okay though. I like seeing things that I don't understand, because then I learn from them, and hopefully I can, one of my other awesome math streamers in my Discord will be able to help. By the way, yeah, if you want to know, we have a whole... I'm not the only person that does this. We have a whole collection of other awesome math streamers. That's an average question, dude. I'm so sorry, Free Fire. That just seems painful, dude.
You done messed up, Aaron!
But anyways, those are the Twitches for our other math streamers, Free Fire. If you want to maybe follow them on Twitch. Also, if you go to... When you go to submit a question here, if you go to streaming schedule... we have a Google Calendar that has all the different times that we stream. And so Zach, E2iPie, he's a math PhD. He might be able to like help you on this one. You can try asking him tomorrow morning, which I think might be an easier time for you, right? Not as late. 11 a.m. Pacific, so like 7 hours before this. Yeah, 6 hours before this. Yeah. But I appreciate. Thanks for coming by and asking it. You know, I will always like look at it at least. But sometimes I know myself. I know my limits. Okay. All right, so that's let's delete one. Let me do Odin roots now. Ooh. This is kind of mathy. Get rid of the Discord. Find the absolute maximum and minimum of f of xy 1 plus x squared plus y squared over the closed triangle plate bounded by the lines x equals 0, y equals 0, and y equals negative 2x plus 2 in the first quadrant. Okay, cool. Okay. So we have, right, it's bounded by, what is it? By this. And then negative 2x plus 2. So that's going to be up here and coming down, right? Yeah, logarithms are totally okay. I can do logarithms. Yeah. So this is 2, and then this is like 1, right? That makes sense? Yeah. You could also like set this equal to 0, set this equal to 0 to figure out where the intersections are. Yeah. This is not pre-calc. This is still calculus though. Because this is vector it's calc 3 because this is a function of x and y. Okay, so we have to figure out what partial f partial x is. And that's going to be equal to just 2x. Partial f partial y is equal to 2y. So then these are equal to 0 at 0, 0. Great. So then I think we just like figure out what that is, right? We're like, oh, cool. What's f0, 0? Well, that's equal to 1. So I don't know if that's a max or a min yet. I'm pretty sure that's a min, actually. Oh, okay. That's very cool. You can actually just by design here, look at this function, right? This will always be positive. This will always be positive. So the only way to get a low number is for these two things to be 0. They can't be negative. Okay, cool. So we already know this is the absolute min. So this is absolute min. Okay. And then I need to go find the absolute max. I think usually you check the endpoints. So like we'll check here, and then we'll see if it's somewhere in between that works. Okay, so at 0, 2. So f0, 2. That's going to be equal to 1 plus 2 squared. Which is just equal to... what is that? That's just equal to 5. And f of 2, 0 is also equal to 1 plus 2 squared, which is equal to 5. I'm tempted to say those are maximums. But then the question is there something in between that's even more? I think then what you have to do is you have to substitute this in for here, okay? So if y is equal to negative 2x plus 2... Sorry, yeah, you're right, Jeff, I fucked up. Yeah, sorry, it's f10, right? Yeah, it doesn't go to 2, 0. Sorry. Yeah, you're right. That's equal to, sorry, just equal to 2. Thank you, fam. You guys are right. I got excited. All right, so let's check in between. If y is equal to negative 2x plus 2, right? Then f of just x, right? That's going to be equal to 1 plus x squared plus negative 2x plus 2 squared. Yeah? And let's see if this has like a max. So this is 1 plus x squared plus 4x squared plus 4 minus 8x. Is that right? 5x squared minus 8x plus 5. Well, I already see this is concave up, right? So this isn't gonna have a max, right? I don't think so. Did we do that right? Maybe I fucked up. But x is limited, correct. Femvox with the level curves, dude. 1 plus x squared. Negative 2x plus 2 squared. 4x squared. Minus 8x plus 4. Yeah. 5x squared. Minus 8x plus 5. When x x is limited from 0 to 1, right? So when x equals 0, you just get 5. And when x is equal to 1, you get 2. Yeah, Lychee, this is the question. If you ever want to see what the question is, that website, actualofficehours.com, which is where people are submitting their questions, you can click here on live queue, and that'll show you all the questions that are being asked right now. So, and we're doing the first one up here. Ooh, interesting. 10x minus 8 equals 0 and x equals 4/5. Wait, what? Yeah. Wait, x equals 4/5. Oh, I see what you're doing. You're figuring out like a critical point. Yeah, but Jeff, this is already concave up. Just like looking at the quadratic, right? So, there's no way for it to really have a max. That would be a minimum. Right? Yeah, Jay, I can definitely help with chain rules. Just submit a screenshot. Yeah, what was it? 10x minus 8 equal to 0. So yeah, x is equal to 4/5. But then the second derivative here is positive. Right? F double prime is positive. So that tells me it's a minimum, actually. Oh, wait. Wait, then what happens at 4/5? Oh, no. But there... Oh, weird. Wait, what? Wait. 5 times 4/5 squared minus 8 times 4/5. Yeah, I don't think it's an absolute minimum. It's a minimum along the line. Yeah, exactly. Because what does that get you? That gets you 16 over 5 minus 32 over 5 plus 25 over 5. So that's 9/5, right? Which is around 2. Right, and the minimum actually happened at 1. So absolute minimum, and then here, this is absolute max. Nice. Good question, Odin. I appreciate it. Thanks, man.
Well done! Well done!
Dun, 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 dun. Okay, cool. I do have the bing bong sound. Yeah. Okay. Next one's from Clickbait. Clickbait, what are you giving me today, dude? Ugh. Lagrange stuff. Fuck. I already get scared here when it says warning, they're pretty ugly. They're still pretty ugly. The max value is 5. And in particular, they're still coupled. Okay. I'm gonna punt on this just because I don't think I can do this right now. My head hurts. Already. But I'll submit it for later. I just don't want to deal with Lagrangian, especially when the question already says they're ugly. I just don't want to do it. Let me see. Where is my thing? Is that a question you seriously have to do in your class? Is that a JEE mains question? It probably is. It looks like JEE. Okay, aviation only. What? I get some really funny people. Oh, you solved the ugly circle thing? Nice. Oh, let's see where you did that. Sorry, that was right here. Oh, thank you, Joseph. Joseph, do you also want the math genius? Here, I'm gonna give you the math genius role. You seem like you're smart in math. There you go. You get a special role. Yeah, okay. Cool. Nice. Okay. I appreciate that, Joseph. That's rude. Clickbait. That Lagrange stuff is, dude, that's so dirty. But also, I mean, you at least have like legitimate concerns. I have no clue what the fuck this is.
You got messed up, Aaron! No!
What is this, dude? Like, why? Why would you hurt yourself?
Disqualified.
Yeah, no, this is getting marked as done. It's okay. Some people do like to just troll, and it's fine. I appreciate the trolls. They're fun. Yeah, it's definitely a joke question. Yeah. Clickbait's is actually legitimate because he actually has homework on it. I'm just... Let me do a couple more of the softball questions, Clickbait. I'll come back to yours. Just in the... But I can tell that question might take a little bit of time. If I had a week off, yeah, exactly right. Why is this not loading? Hold on. There we go. This is unsolved. But probably trolling. Okay. Let me see the next one. From LOL. Ooh. Can I answer this? Maybe. Nerdwino, what's going on, dude? Shout out, Nerdwino. You legend, Nerdwino. Shout out, Nerdwino. Nerdwino's an awesome streamer. He does a lot of like NASA, space, and astronomy stuff. If you want to go check him out, he's another amazing science Twitch streamer. Super cool guy. Clickbait says that integral would take 2 hours. Yeah, it would have been, dude. Yeah, this is a joke. This is not happening, dude. This is not a real question.
Oh, no.
That's so sad, dude. I'm not doing that question. Okay, this one I might be able to do, though. Yeah. Yes, so fun, Arduino. I really enjoyed hanging with you. Yeah. You're all good. I did text you. I texted you at like probably like midnight or something on Saturday night. I was very many vodka Red Bulls deep at that point because I don't know did you go to the Vodka Creator Club tent next door? They had free sushi, like Nobu sushi and stuff. Yes, the optimism of messaging you at 11. I was out till probably 4 a.m. that night. Some Twitch rep was just buying me shots like all night. It was this girl in like Twitch marketing or something. She just, I guess she just had like company budget and just kept spending stuff. Yeah, it was awesome. Yeah, the Red Bull Creator Club thing was. I didn't pay for any food all weekend because they just always had food and drinks there for free, for us. It was really nice. But also, yeah, that's why I was up pretty late Saturday night. Sunday was kind of a struggle. Okay. Let U be the subspace of R4 described by this. Find a basis for U. Oh, good. Yeah, you saw it on Sunday morning? Yeah. Did you go inside of it? Like, I went there Sunday morning just because I really needed something to eat. And they had free tacos. Like, catered tacos. It was really nice. What was this 3, 6, minus 5, 4? And then what is this? This is gonna be like... Oh, you were literally you were actually getting exercise. Oh, okay, nice. Cheers to you. You were actually being healthy. Yeah, I was there nursing a hangover. But... They bring that thing to F1. It's a massive, like, 2-story building. 3-story building, actually. Yeah, that's very cool. Find a basis for this, they say. I was just doing linear algebra with someone. I should be able to do this, right? Chat, am I doing it the right way? Am I setting this up the right way? I forget if I'm supposed to do it, like, horizontally or vertically. Yeah, next year in Arduino, definitely. We got to go in. I got to bring it to it. Someone told me about it because they saw it on Instagram. I guess they're called activations. Like, different companies were doing things outside of TwitchCon that if you had badges and whatnot, you could go to. It was really cool. I'm definitely going again next year. It was such an amazing time. I met so many awesome people, yourself included. And it was so nice to see all the streamers in real life. And I have so many ideas now about things moving forward. Yeah. The last 4 in your matrix should be a 1. Correct. Thank you, Femvox. That is true. That's awesome. Yeah, for a solid three months. So we need another TwitchCon. You know what? I'm thinking about going to an Arduino. There's apparently VidCon in Anaheim in June. Which is like for YouTube, which I think I will hit 10K by the end of this month for YouTube. So I think I can justify going to VidCon. Okay. Yeah, it would be really cool, right? Yeah, VidCon, it's in Anaheim. And so that might be a nice little stopover before like TwitchCon in, October. I forget if you do stuff on YouTube and Arduino, but I get a lot of nice discovery on YouTube. We do call these matrices. We definitely do. One sec. Nice, 3 vids a week. Awesome. Okay, great. Yes. Then yeah, YouTube. You should try streaming in vertical to YouTube if you don't do that already. I get a lot more discovery on YouTube for the verticals. Yeah, and shorts. Shorts are great. Yeah, I do a lot of shorts. In Australia, they also call them matrices. That's great. All right, I think I need to row reduce this thing. Let me like multiply this by 3. 3 times R1. Or, sorry, negative 3 times R1 plus R2. And let's have that imply row 2. So what do we get? We get 1, 2, Sorts? I prefer pants. Shorts, not sorts. Shorts. Okay, that's 0, 0. Oh, wow. Watch this. -9 minus 5. Around here, we put a word before the matrices, but I won't say it. Feckin' matrices. -12 plus 1 is -11. Oh, I think this is already row reduced then, basically. Okay, then we can divide by 14. Yeah. Fucking matrices. It's okay. 1/14 R2 implies R2. I think negative though, right? Yeah. Okay. So then we're left with 1, 2, 3, 4, 0, 0, 1, 11 over 14. Okay, cool. Okay. This has, and then I need a basis for this. These aren't high school. This is like early college, Ricardo. This is called linear algebra. Mm-hmm. Yeah, exactly. Okay, so from this, I know that, for instance, x3 is equal to a negative. Wow, watch this. So 1x3 plus 11/14 x4 is equal to 0. This already tells me this is only gonna have dimension 2, right? Because it's only rank 2. It's a rank 2 matrix. But then if I want to come up with a basis for it, I need something that like solves this. So from this, hitting this. So this multiplied by this, you get that x1 plus 2x2 plus 3x3 plus 4x4 is equal to 0. And then from this, you get x3 plus 11/14 x4 is equal to 0. So x3 equals -11 over 14 x4. Right? And then I can replace that now for here, right, to get x1 in terms of x2 and just x4. Okay, so now x1 plus 2x2 minus 3/33 x4 plus, let's say, 4 times 14 is 56 14ths x4 is equal to 0. So x1 plus 2x2 plus 23 over 14 x4 is equal to 0. Okay. Okay. So x1 equals -2x2 minus 23 over 14 x4. Okay. All right, now I have an expression where I have x1 in terms of two different variables. Nice. Yeah. Thanks for coming by, dude. Moink. Appreciate you, dude. Okay. All right. Because it's a it's a 4-dimensional matrix, but we only have 2 we're only rank 2. That means I need to have 2 like free variables basically, right? So, I'm going to write this in terms of like A and B. So, I'm going to say that x1 is equal to -2a minus 23 over 14b. Then x2 just equals a. x4 is equal to b. So look, watch this. Plus 0b. x4 is equal to 0 plus 1b. And then x3 is equal to negative 11 over 14b. Okay. So if I wanted to write this as a matrix in terms of A's and B's, that would be x is equal to negative 2, comma 1, 0, 0, A plus negative 23 over 14, 0, negative 11 over 14, 1, and then this is B. Okay, cool. All right. So this is my basis then, right? This is my basis? Yeah, okay. And then, well, the basis can be multiples of it, right? So your basis is then negative 2, comma 1, comma 0, comma 0. And to make this nicer, just multiply the whole thing through by 14. So negative 23, 0, negative 11, comma 14. You should solve some time travel using black holes? What? Sounds scary. Okay, cool. I think we did it, right? They said, what's the basis? What's the dimensions? The dimension's 2, right? Basis is that dimension equals to 2. Okay. Write down the matrices A and B such that U equals kernel A and U equals kernel basis A. What? What's going on here, sir? What? U is equal to the kernel of basis A. Ryan says, maybe this is a question for Nerduino, dude. Black holes. I don't know the physics, but apparently you should solve some time travel using black holes, but apparently there's a theoretical physics and coordinate system that allows something traveling near the speed of light to exit the black hole in the past. Whoa. Is that like the, what do they call this? Like the reverse spaghettification? It's where things get like stretched out like spaghetti. Okay, U is equal to the kernel of A. That's just the original matrix then, I guess. Oh, and then I is... Sorry, what is I then? What is I? Oh, that's the image. Oh, and right, doesn't the kernel and the image have to, like, add up to the... Okay, I think I'm gonna get this way. One second. Okay. Okay, U is equal to kernel of A and then image of B. That's where AX is equal to 0. Okay. And we already knew what that was. A was equal to this thing. We already came up with this. I remember all my linear algebra terms. Oh, man. Like kernel, image. Okay. Okay. Okay, and then U is equal to image. Yeah, exactly. Yeah, no, I got you. Yeah, it's... one sec. This is where I need, like, Paul's math notes. Kernel, basis, dimension, add up, something like this. Or, I'm thinking... Sorry, the nullity is what I'm thinking of. I hate matrices. That's what Arduino said, dude. Feckin' matrices. Oh, man. Okay, here we go. The dimension of the kernel is the number of vectors in any basis. It's also called the nullity. Man, but wait, I remember... Oh, here it is. Okay, where was it? No, this is it. Okay. Rank plus nullity equals the number of columns in the matrix. This is the important thing I'm thinking of here. Okay, here we go, jokes. I think I got it. This is what I wanted to say. Okay, jokes. So we had a 2x4, right? That's what our original thing was here, right? We had a 2x4. And then we figured out that the rank of this matrix, so when you row reduce, that got me a rank of 2, right? So this was equal to A. A was a 2x4 matrix. The rank of A was equal to 2. You get that from just doing row reduction, and you just see, like, how many non-zero rows you have. Or that aren't, like, duplicates. Well, if they're duplicates of each other, one of them turns to a 0. And so that means the nullity must be 2, because rank plus nullity equals n, which in this case was 2 plus 2 is equal to 4. Okay. And the column space, okay, the column space, this is the basis vectors. So when we do this, when they say the image of B, I don't know why they're saying the image of B, by the way. Sorry, what? Okay. This is, okay. B is a matrix such that the image of B is equal to U. Okay, I get what they're saying here. So then B in this case is just your basis vectors written as a column. So that's going to be minus 2, 1, 0. Minus 2, 1, 0, 0. And then minus 23, 0. Minus 11, 14. Kepler's laws. Submit a question. Submit a screenshot. I'll do it. Okay, cool. Write down a subset of the columns of A that forms the basis for image A. I think we already did this. Wait, I think we already did all these parts. We did it in reverse. Okay. I'm going to mark that done for as well as I have so far. Yeah. I think we already did part C, but double check it with me. All right, whose was that? That was LOL's. Okay, lol. Interesting question. All right, Mark is done. Ooh, okay, cool. The big rat next. This looks like a calculus question. Spread knowledge. Oh, thank you, Smiley. 20 euros. Holy shit. Fuck yeah, Smiley. Thank you, dude. Yeah, spread knowledge, not brain rot. I appreciate that. Wow, thank you, Smiley. I think it's the biggest donation I've gotten. Actually, it depends on the US dollar. Sibley donated $19.99 to me once. So I'm curious, but thank you so much. That's awesome, Smiley. Appreciate it. Okay, find dy dx and simplify your expression. Oh, arctan. Okay. Is this just like a chain rule? I think it's a chain rule, right? I need to look up what the derivative of arctan. I think it's 1 over 1 plus x squared. Sam says W. Yeah, look at that. Big dubs, dude. This is why I love streaming on YouTube. Because we get a lot of discovery. We just get people who would never find us normally, and they happen to see us in the shorts feed. And then, yeah, some of them are like, you know, hell yeah, I like what you're doing. I'm like, thank you. I raised the question at TwitchCon for the CEO of Twitch. I said, yo, you need like an education category. He said he would get back to me. He hasn't got back to me yet. Okay. This is a chain rule. So the cool thing here is when I take the derivative of this, I can take the derivative of each thing independently and then just add them up at the end, okay? So really quickly, this one I already know is this, right? Wow, now I win. Enjoy your evening. Oh, shit, 50 euros. Fuck. Oh, that's dope, dude. Oh, dude, hell yeah, dude. Appreciate it, dude. Wow, that's super dope. Thank you, dude. Yeah, I'm gonna have, that's the biggest donation. UG Smiley, dude. I don't think anyone's gonna top that. Well, I hope they do, but I don't think anyone's gonna top it anytime soon. Alright, let's do some derivatives. This is this. This is a little trickier. Thank you for everything, man. You're actually carrying my pre-calc. Hell yeah, dude. Yeah. I have a bunch of videos, little short videos I have on some, like, very commonly misunderstood topics. If y'all are watching from YouTube. Just go here to, like, playlists. Or even, I think I have it under courses, actually. And here, it's like math in 60 seconds. I have a bunch of just, like, short videos I've written on things that students always get wrong. Like, I think someone was asking about factoring big polynomials earlier. I have, like, a 3-minute short on how you do it. So just look through this list and see if it's on there. If not, feel free, again, you can join our Discord on the same website. You go to, like, submit questions here. You can go to, like, join our Discord. And just send me a DM of, like, something you think would be a good video idea, and I'll work on it. Your videos are helpful as hell. Fuck yeah. Thanks, dude. That's how I started doing this, honestly. I was making videos, and then that helps to get people in for live streams. Odin says, I remember doing this thing at my exam. Yeah. You'll see it's a trick question. Is it? Okay, well, here we go. So I don't know what the derivative of arctangent of 1 over x is, but I do know what the derivative of arctangent of something is, right? So I'm going to say, okay, I always say, like, call this thing box. That's what I do. I call this box. So then dy dx is equal to, like, the derivative of arctangent of box dbox. And that we know is equal to 1 over 1 plus box squared. But then the key thing here is that you also need to multiply by d box dx. This is the chain rule part. D box equals dx when? And we're going to do it right now. Yeah, exactly. So then, cool. D box. Well, then you can figure out what d box dx is, right? So this is, remember that box is 1 over x. Okay, so then we do the derivative of 1 over x dx. Okay. And so this becomes equals to 1 over 1 plus 1 over x squared times the derivative of 1 over x is negative 1 over x squared. And cool. And so that's this part of the derivative. Okay, so we have 1 over 1 plus 1 over x squared times negative 1 over x squared plus 1 over 1 plus x squared. That part came from this. Right? Someone says this is going to be a trick question. Does this just go to 0? I think it does. Because watch, when I put this in... Oh, this is so cool. So I get negative 1 over x squared plus 1 over 1 plus x squared. Oh my god, it is 0. 0! Oh my god. Okay, but why is it 0 though? Okay, that's cool. Fire, right? That's a dub, dude.
Bing bang.
So what was it? If I just graph this, we could just go to Desmos. It does, yeah. Isn't that cool? Lineatrix. Jeff says in a right triangle, the tangent of one angle is 1 over tangent of the other angle. So the sum of oh, this is a constant. Oh, that's so cool. Yeah, I see what you're saying. What's up, Uncle Bill? Welcome to the stream. In a right triangle, okay, yeah, sorry. Yeah, so this is what we're saying, right? So if you have a right triangle, and let's say this is like theta 1, this is theta 2, and then this is 90, right? Theta 1 plus theta 2 always equals 90 degrees. So that's pi over 2. Bro's deriving with respect to purple. Yeah, dude. I think it's just easier. Like, de-purple. Okay, so the tangent, let's say of theta, let's say theta 1, right? That's equal, let's call this y, let's call this x. That's equal to y over x. So that means the, I think I see, no, I think I see what's happening here. Oh, this is very cool, actually. Very cool. Wait, watch this. Okay, sorry. Arctangent of, let's say, y over x, right? So opposite over adjacent. That's equal to theta 1. And then the arctangent of 1 over y over x. So that's x over y. So opposite over adjacent. That's equal to theta 2. Oh, beautiful. And theta 1 plus theta 2 is always equal to pi over 2. Oh, money. That's a constant. Derivative of a constant of a number is just equal to 0. Oh, wow. Oh, we didn't send? Oh, no. Okay, cool. Very cool. Very cool question. Oh, no. Go away, Travis Scott. No, sorry. This one. There we go. Not Travis Scott. What's his name? Lil Yachty. Ah, that's cool. Lineatrix says I can also, from this we can also say that that is true. Nice. Good question there. Who was that? That was the Big Rat. Thank you, Big Rat. Thank you also for asking that question 2 hours ago. So I tell students it is important to try to get here early, or if you just want to hang around, you're going to learn stuff. We do a lot of cool questions. Like, this was a linear algebra question. This was a troll question. This was more vector stuff. And then, yeah. Did we do some physics earlier? I think we did physics. Yeah, we did physics. This was physics. Big brain, Uncle Bill. Yeah, hang around, dude. You'll learn some stuff. All right. Let's mark that as done. So, that's going to go into our Discord here. I vibe coded this bot over the weekend. But that image gets sent in, and then I just drop the screenshot in, and it gets the answer. Well, if it wants to download today. Right. There we go. Nice. And there's a solution. Answer is 0. That's actually really cool why that one is 0. All right. Oh, man. Who's asking me about Whiteman and Feynman functions? What? Okay. No, I don't know how to do this. But I will still send it to our Discord. Blackwell, I appreciate you asking really tough things. I will put it as like unsolved. So yeah, if you're watching my stream and you feel like you could answer this, again, I didn't really go. I did experimental plasma physics for my PhD, so I didn't really do much in terms of like Feynman diagrams or Feynman equations. Please join our Discord, and then I'm gonna mark this one as unsolved. And so, if you want to go solve that, yeah. Surely not my first time here, though not very often. My Twitch usage dropped. It said it was your first time chatting, at least. Ryan says, fun graph problem. I am that Uncle B. Oh, from TKF. Oh, cool. Okay, yeah, I know TKF. All right. Midget Mucker. That's an interesting name. I don't even know what that means. I bet it's something that I'm not supposed to know. You kids with your screen names. All right, but you are asking about Vesper diagrams, and this is cool. We can do this. Oh, you found the solutions? Oh, let's see. Oh, okay, cool. Love that. Yeah, let's post that in for him, actually. There we go. It's an MIT problem set. Wow. I already did most of it. Okay. You just want me to check whether it's right? I need a diagram for this, too. I need molecular and... I think it's... Is it called electron geometry? How about you make a thread? Oh, in the thing? Yeah, sure, I can do that. Okay, it should have one. Yeah, I just did it. I'm trying to find which one I like. I think I like this diagram. Steric number. I forget which one I like. No, I don't like that. Okay, cool. Thank you, Joseph, for finding that. Lewis.Vesper. Oh, wait, you're doing all this hybridization stuff. Wait. Lewis. Yeah, I see what you're doing. I don't think you have to draw the hybridized states. Yeah, I saw it. I saw it, Joseph. Yeah, it's here in the Discord here. So I see what you're doing here with the hybridization. I don't think you have to do that. He wants it. Oh, okay. That's kind of annoying. Oh, yeah, you're right. When you write, you write, dude. It says draw the hybridization. Yeah. I got you. I feel like you can get the hybridization, though. Just from, like, the number of bonds and stuff. Right? Correct me if I'm wrong. Can I just add that d orbital hybridization is actually fake and isn't real? Oh, is it? Why? What is the rule, though? There's some rule for, like, if it's how many bonds, it's like SP, SP2, SP3, SP3D. I'm trying to remember how it works. I know you can do this. I don't really want to do this. Yeah, okay. Because then there are these diagrams, right? What are these diagrams called again? Yeah, hybridized orbital energy diagrams. Turns out if you're a metal, d orbitals don't really do anything. Yeah, have you seen these before? These are common. Yeah. Hybridized orbital diagrams. I've always just done the number. Okay, thank you, Origin. That's what I'm looking for. It's the number of attached things minus 1. Yes, right? For SP. Right? Like SP, SP1, SP2, SP3. This is where, like, it's like pi bonds and sigma bonds and stuff. This gets, like, a little bit more involved. Do you understand standard model? I don't. No. I don't understand the standard model. Well, I know what it is, but I can't really derive it. Alright, let's just see what you have so far. So over ethene, it has 3 groups. It makes sp2. So let's see what we're talking about here. So yes, sped. Yes, I remember that one. Okay, yeah. Atoms or lone pairs. What about bonds? Like, does a double bond count as 2? Or is it just 2 things are attached to it? So, for instance, he has here for CO2. So carbon has... I always need, like, a periodic table real quick. Periodic table. This is the thing with chemistry. You need, like, all these things. Okay. So carbon is +4. A double bond counts as 1 group. Okay, great. So you have 4 electrons from the carbon, right? Yeah, okay, 1, 2, 1, 2, 3, 4. And then each one of the oxygens has 6. Right? So yeah, wait, why didn't you draw the oxygen ones then? I see you drew it for carbon. Why don't we draw it for oxygen? Because here's the way I would do it. So carbon is 4. Oxygen is 6, but times 2. So that's equal to 12. 4, so 16. So, and then I'd like divide this by 2. So you have 8 bars to mess around with. So you know carbon has to at least do this, right? And then I get 8. So 1, 2, 3, 4, 5, 6, 7, 8. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So that's too many, right? I've used 10. So you have to like double up on something. So what you do is like you move this one over here. You get rid of this. And then you move this one over here, and you get rid of this. Because I think this is like, what do they call it? Like, formal charge favored. Good. Okay, the oxygens are not hybridized. Yeah, okay. So then carbon is just sp, right? Yeah, sp hybridized. Okay, cool. And then this is just linear. And it's also nonpolar. I agree. I agree with all this. Interesting. Joseph says the oxygens are sp2 hybridized. Oh, okay. Because they have 3 things around them. Thanks, Joseph. Yeah. Joseph, our resident chemistry expert here. I know a decent amount of chemistry. I just kind of forget some of it. But yeah, okay, because this is a bond. This counts as 1, and these are 2 lone pairs. So that's sp2. Okay, cool. So this is sp2. This is sp. This is sp2. Okay, cool. The CEO of chemistry? You want me to give you, like, CEO of chemistry? I'll make a special role for you. Okay, cool. At your service. Appreciate it, dude. But as a whole, is it SP? Like overall hybridization? I don't know. I think you have to talk about the hybridization of each individual thing. Orange Dank Drank says it has a mix of s and p orbitals using to make the bond, so it is hybridized, yeah. I mean, maybe when you talk about the hybridization, you always talk about the central atom. Yeah, Joseph says hybridization only makes sense talking about each atom. So, I think if you're talking about the central atom, it's SP. Okay, cool. Yeah, central atom's fine. All right, let's look through your other 2 real quick. Just check them for you. I'm not gonna do them because you've already done them, but I'll just check. SO2. Wow, yeah, you're doing what? The pi bonds and the sigma bonds? That's a lot. Yeah, what is S? S is S is the same as oxygen, so 18. Okay, cool. So, sorry, 18 divided by 2, 9. So let's see, do you have 9 things? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. Cool, I agree with that. Yeah. Sulfur has to have an extra lone pair on it. This is, yeah. I mean, the most formally charged favorable thing. Cool. And so, then we say that it's sp2 hybridized, right? Because it has 1, 2, 3. Okay, cool. I agree with that. I3 minus. I is 7. So that's 21 plus 1, 22. 11. Let's see. 3, 6, 7, 8, 9, 10, 11. Cool. I agree with that. And then this is 1, 2, 3. Is this sp3d? Is this the D one that doesn't exist? And wait a minute. Is this linear? I don't think this is linear. Wait. Oh, it is. Sorry, there are 3 things. Yeah, it has to be. Fake. Joseph says it's fake.
Oh, no.
Okay. Cool. Yeah, it is linear. Yeah. I think so. Yeah. Wait, Joseph says yes. Okay. Aufbau. Yeah, the Aufbau. Aufbau principle is nice. That's just, to me, this is kind of weird though, Joseph, to have what, 3 lone pairs? Is that a thing? I'm trying to think from like here, right? I guess it has to be, yeah. No, wait, T-shaped. Yeah. Well, wait, the center thing has 3 lone pairs. I'm actually now I'm kind of doubting this. Row 5, column 3. Oh, yeah, duh. Okay, it is still linear. Yeah, that's this one. Thank you, Joseph. Yeah. Yeah, this is a weird one. I was like, what? Yeah, it's to the right of T-shaped. Okay, got it. Got it. Okay, cool. Then XEF4. Yeah, this is a well-known one. This is one that disobeys the octet rule for sure. Cool. 6 groups always attached, always in my brain. Yeah, but that's the expanded octets. Okay, we'll check up. Sorry, wait. This is even more ridiculous. SP3D2. Does that exist? This one I know. I know of this one. That one's easy. Okay. What was the other one? IF4 plus. Let's do that one. Doubly fake. IF4 plus. Okay, they're both 7. Okay. So that's 34. 34 electrons. So I divide by 2. 17 bars to mess with. Okay, so you have I here. You're gonna have to connect at least this. Yeah, it's like a good enough approximation for us. Okay, that's 4. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So 3, 6, 9, 12, 16. So then there's just 1 lone pair. Yeah. I agree it's SP3D, but so I think it's this. So you have 4 attached and 1 lone pair. So that's seesaw. Yeah, I think it's seesaw. For IF4 plus. Seesaw. Okay, nice. Yeah, good question. I appreciate the chemistry. Cool. All right, Midge. Good question. I'll add that. Also give you a coin. Anybody else who has coins who answered questions, I'll do them later today. I just want to make sure you're new to our server, Midget. So there you go. Thank you, Olaf. Bless you. Okay, sick. All right, next one's Nathan. Okay, interesting. Evaluate 1 squared minus 2 squared plus 3 squared minus 4 squared and sine of theta, plus sine theta, sine 2 theta, sine 3 theta? What? Excuse me? Okay, I don't know. What is this? This is 1 minus 2, 1 plus 2, plus 3 minus 4, 3 plus 4. Does that help us out at all? I already see some difference in squares. This I know. These are some weird identities. Jeff says it's -1 times the sum of the first n integers. It technically diverges, but there's stuff called Ramanujan summation that assigns an answer to this. Oh. Y'all asking some weird-ass questions here, dude. What? Wait, here's my question. Is it this plus this? Are these two things together, or is it evaluating these two things separately? Can we go back to chemistry? No, Jeff loves the math. Jeff says anything but physics. Okay. Everything is happy. Yeah, they can't hurt us there, right? Okay.
Nice.
Wow. Thank you, Ninja. Appreciate it. Okay, interesting. I like the math too, Jeff, he says. I feel like this eventually just goes to 0, no? Okay, let's try to write this as a summation. So it's a summation, n equals 1 to infinity of n squared. But then there's like a flip-flop on it, right? Ooh, Tidal Wave says if you split it into a difference of squares, it turns into summing each number in series times -1. Divergent. Okay. I mean, that was my original thing, right? I saw this. I was like, cool, this is 1 plus 2, 1 minus 2, plus 3 plus 4 times 3 minus 4, right? Plus 5 plus 6 times 5 minus 6. Summing each number in series times -1. How does that work, sorry? Oh, wait, whoa, 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 whoa. Oh, I see. This is -1. This is -1. This is -1. Oh. Oh, that's super cool. Oh, so it's -1 plus 2 minus 3 plus 4 minus 5 plus 6 minus 7 plus 8. Wait, isn't this divergent then? Divergent, yeah. I found the solution for this question when I put in Google search online under Harvard Advanced Analysis. Are you in our Discord? I'll create a topic for it. I don't think I've seen that. One sec. Sorry. Here, I'm going to mark this one as done. And so then it'll show up in our Discord. Wait, where is it? There it is. So this is it. There's Nathan's right here. So I get the feeling that this is divergent, and then Yeah, Steven, if you're in our Discord, there's a channel here for it. It's just called Nathan. It's Nathan's question. Some of y'all be asking me some very interesting ones to go through. Okay. Oh, Jesus. Okay. Frog thick. Thank you, Stephen Curry. Let's see what that is. So that says... If theta is a multiple of pi, it's just always 0. Yeah, okay. Okay, we'll evaluate the limit as r approaches 1. It's equal to 0. Oh. Oh, bless you, clickbait. 2 hours later. What is this crackpot mathery?
You done messed up, Aaron!
This is some crackpot mathery, dude. Abel, what? Who the fuck is this Abel guy? Yes, Illick, I can totally... Yeah, submit a screenshot of your quadratic word problem. I'll do it. Okay, cool. I'm going to conclude that this question's kind of done. So I can just move on. But thank you for finding that solution there, Steven. I think it's divergent, but I'm obviously wrong because someone at MIT is smarter than me. But it happens. Cool. Good question, Nathan. Joseph, want to compare? Yeah. Let's see how ugly is it, dude?
Well done!
Advanced real analysis from Harvard. Yeah. We do be getting that sometimes. I call them like my YouTube math warriors. There's some people that dude, whoa, what? Dude, how did you get this in rainbow, dude? Wait, how did you do this? Lineatrix, this is dope. Rainbow math? A billion? Yeah, maybe a billion. Okay. Find the inverse Laplace transform. Ooh. I kind of like Laplace transforms. Is that all in tech? Did you write that all in tech, Lineatrix? It's impressive. Okay, I have to remember how this works. Do I have to... Oh, just answer one. Okay, Alec, you're good. I need like a Laplace table. Bingo. Wait, what? No. Sidud says, need to solve an integral. Sidud, there's some good questions that have already been asked. Welcome, good morning. Okay, what is this? Okay, so the Laplace transform of e to the at, f of t is f of s minus a. Okay, so need help with a category theory proof? Submit it. Submit a screenshot. I have some really smart math people in my Discord that might be able to answer it. Yeah, dude. The algorithm knows what you're doing, dude. TikTok knows everything you do. So, yeah, sorry. He's like, I was just doing Laplace transforms. Okay. So wait, is e to the minus... What happens if it's e to the minus at? E to the at is 1 over s minus a. Oh, wait, here we go. Sorry, this is what I was looking for. E to the minus as over s. Oh, Laplace is going this way then. Oh, okay. Yeah. If you go to the website down there, actualofficehours.com, there's a link to my Discord. Or, I mean, it's our Discord, it's not really mine, but... Okay. Okay, this is what I want. I want this. Let's use this one. So this tells me this is going to be, f of t minus a. And then it's u t minus a. Right, that comes from this. Where big F of s was equal to 1 over s squared plus 1. Uh-huh. And then we have to do... So we have to like break this up. Okay, and then there's like a shift to this. Yeah. No, use a function. Use a function jokes. Yeah, it's function t minus a. It's not union. Okay, but this I think they call this like f naught of s. Is what they call it technically. Okay, let me do partial fractions. And then was this 1 over s squared plus 1? So what? That's a over s plus what is that? bs plus c over s squared plus 1. So s squared plus 1 times a plus bs squared plus cs has to all be equal to 1. Okay. So a has to equal 1. Right? Because here we get... Okay, so this is a plus cs plus b plus 1. No, b plus a. S squared has to all equal to 1 plus 0s plus 0s squared. Okay, so c equals 0. Okay, so a equals 1, c equals 0, and then b must equal minus 1. Ah, okay, cool. So this is then equal to 1 over s minus 1 over s squared plus 1. Ah, see, this is where partial fractions comes in. Okay, cool. Ugh. Yeah, because this is a shift, is what this is. If you have e the minus as of f of s, that does a shift at t minus a of what the original thing is. Okay. So then you're doing, Yeah, okay. You have u t minus a, and that's f of t minus a. So that's going to be f of... You can use the linearity of a Laplace transform. Ugh. All right, I need to think. Sorry, there's a lot of stuff going on here. Laplace of f of t equals f of s. This is f of t. Okay, so f of t is also equal to the inverse Laplace. How do you draw like that, right? Of f of s, right? Okay. Are things commutative in Laplace transforms? I think so. Okay. So, this is what I'm going to say. The inverse Laplace of big F of S is equal to the inverse Laplace. I'm running out of room. Fuck. Ugh, fuck. I'm just going to get small. Inverse Laplace of f of s is equal to the inverse Laplace of e to the minus as. And then let's call this... Is this differential equations? No, this is... What is this? What math would this be? I'm going to call this like another f of s. I'm going to say this is like f naught of s. There's too many f's here, right? Okay, cool. Which that is equal to... Right, you can act the Laplace on both of these, right? So then this is ut minus a. And then whatever the Laplace transform is of f naught of s. But f naught of s is equal to... This is the linearity you guys are talking about, right? 1 over s minus 1 over s squared minus 1. This is university for sure. So, inverse Laplace transform of this is equal to the Laplace transform of 1 over s, which is just 1. Here, and I'll see where that comes from. So 1, that comes from this one. And then s squared plus 1 is this one. Or purple. Okay, and then we're going to say minus sine of just t? Or no, oh, wait a minute. Sorry. I got this wrong. B is equal to minus 1. This one survives. Aha. Okay. Okay, in that case, it's this one. And it's cosine of t. Got it. Okay. So now, this whole thing here is equal to u t minus a f of t minus a, and this is f of t, which is equal to u t minus 1, u of t minus 1, 1 minus cosine of t minus a. Right? Okay, cool. Where this is a shift, right? Sorry, this is not t minus 1. This is t minus a. I don't know if I was writing 1. T minus a. Right, and so you could also write this piecewise, right? So this is cool. This means like the function is 0 until t equals a. So if you wanted to write it out like this, right, and that comes from, where is it? It's the delta thing. Yeah, it's a delta function. So I think f of t, we would say then, is equal to 0 for 0, right, less than equal to t less than a. And then it's equal to, this is 0 until t equals a, and then it's 1. So then when this becomes 1, then you have 1 minus cosine of t minus a for t is greater than or equal to a. Okay, cool. Sorry, it's not the Dirac, you're right. Sorry, it's not the Dirac delta. It looks like Dirac delta is only 1 exactly at that position. What's it called where it's 1 if it's greater than that? Is that just what the U thing is? Yeah. No, I'm a physics professor at UCLA. I teach physics. Oh, we hit the end of our music. I've been teaching for so long today. That's what the U of T is? See, that's what I thought it was. Okay. Wait, come on, music. Let's play it today. I need my tunes. Okay, I gotta restart this. It's not loading today. Come on, internet. Okay, let's download this one. Whose was this? This was JW. Okay, cool. Download. Let's mark it done. Let's throw it in. And there. There it is, JW. Nice. I want my music to load. What the fuck? Dropbox. Who pays your bills? I pay your bills, Dropbox. Come on. Oh, chronic or delta? Is that what it is? There we go. Music is back. I was getting frustrated. Okay. Can I explain sigma F equals ma? Yeah, that's just F equals ma. It's not too bad. Sum of the forces equal to mass times acceleration. You can submit a screenshot of a question if you want. So like that's what people are doing here. The queue's not too long. Ooh, okay, this is cool. Yes, Laplace transform is used every day in electrical engineering. It's used in a lot, yeah, for sure. Jack says, not gonna lie, you don't look like a stereotypical smart person, but you definitely are. I get that. It's okay. No, I understand. And I think that's honestly what kind of the appeal is that I don't look intimidatingly smart. All right, I'm gonna extend office hours a little bit more time just to get through these questions. We're going for 4.5 hours. Extra 30 minutes on the clock. Nick says, I'm mainly stuck on equating the 2n plus 1 part. What's your degree? Plasma physics. I have a PhD in plasma physics. Expand. Prove by induction that n to the 5th minus n is divisible by 230 for every odd positive integer n. Okay. So is this just the binomial theorem? Just like n choose k something, right? Yeah, right? What is it? Oh, you want to? Yeah, are you in my Discord? I mean, you can also submit the screenshot again if you want. That's fine. Yeah, just submit a new screenshot of your solution. Let me just see it. We've been on for 3 hours. Long time. Yeah, submit the screenshot. I got you. I think Pascal's triangle is easier. Yeah, that's the 1-1-3-1, right? Is that what we say? Is that this? 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So wait, this is to the first, to the second, to the third, to the fourth. Okay, we gotta do to the fifth. 1, 5, 10, 10, 5, 1. Okay. So what is that? That's 2k to the fifth plus 5 times 2k to the fourth. Oh, okay. But then it's remember the 0th. Yep. So this is like, I think this is -1 to the first, right? And then it's plus 10 2k to the third, -1 squared, plus 5 2k to the second, -1 to the cubed, plus 1 times 2k to the first. -1 to the fourth. Did we miss one? What do you got for lineatrix? What do you got for me? Oh, this is beautiful. I don't even know what the hell this is, but this is so pretty. I think I'm missing a row too. I think I am too. Shit.
Disqualified.
What did I mess up on? Oh, wait. This is first power, second power, third power, fourth power. No, it's fifth power. What did I screw up? 5, 4, 3, 2, 1, 0. One. Oh. Sorry. It starts at 1 at the top and 2 ones below. Oh, shit. You're right. Wait, what? Is it like that? Wait, sorry. Is that how it starts? I think he has it submitted, Joseph. Oh, my thing's all screwed. Sorry, did I do this right? Yes, okay. Can I show the question? It's up here. Oh, okay. This is to the 0th power. To the first, to the 2nd, to the 3rd, to the 4th, to the 5th. Wait, so what did I screw up then? Sorry, 1, 2, 3, 1, 3, 4, 1, 4, 5, 4, 6, 10, 6, 4, 10. Yeah, is this not Pascal's triangle? Did I fuck this up? Wait, let me see what he submitted so far. Okay, let's see. I thought I had this right. That's the expansion part, yeah. I see. I mean, it's probably right. Can't you just use number theory? I mean, I want to, like, expand it, right? I know this is, like... This is 2k to the 5th. Times, what is it? Plus or minus 1. To the 0. Plus 5 times 2k to the 4th. Times plus or minus to the 1. Plus 10, 2k to the 3rd, plus or minus 1 to the 2nd, plus another 10, 2k squared, plus or minus 1 to the 3rd. Plus 5, 2k to the 1st, plus or minus 1 to the 4th. Plus 1, 2k to the 0, plus or minus 1 to the 5th. Okay, that's the full thing. And then I'm going to assume you expanded this correctly and collected the like terms. Let's see, 32k to the 5th, minus 80, 80, yeah. Okay. Cool, that looks all good, right? Okay. All right, prove by induction that n to the 5th minus n is divisible and divisible by 240 for each positive integer n. So, right, induction, you assume it's true, right? Okay, cool, you did this, right? You said, oh, well, p of 1 is true. Wait, no, p of 1 is not true. What? Wait, what? 1 to the 5th minus 1 is not divisible by 240, though, no? Wait, what? 0 is divisible by 240? Oh, because it's 0? Okay. You mean like it's 1 to the 5th minus 1 is 0. Okay, but what about for like n equals 2? Sorry, what? Oh, n equals 3. Oh, I see. I see what you're saying. Yes. Yeah, 2 is not even. 3 to the 5th is probably good though. Yeah, okay. Okay. Okay, so you assumed it worked for that. Okay. And then you assume that, right, if it's an odd number, it has to be 2m plus 1, right? That's the classic way we represent odd numbers, right? Proof by modular arithmetic. What's up, mathematic fanatic? Good to see you. Yeah, okay. I would say I like 3 better, right? It is the same. Totally cool. Yeah, that's all good, Nick. Okay. Okay, so assume you can do 2m minus 1, that's fine. 2m minus 1 works. The next one that would work right? So that means that 2 times m plus 1 minus 1 should also work, right? All right, now let's see. Why did they give us this first thing, by the way, though? Like, why did we care about this? Oh, is it because all these things are divisible by 240? No. Because you're gonna need, because you're gonna need to expand those. Okay. All right. Let's see. Mod proof is so much better, though. I literally hate induction. Yeah, induction, it gets tricky sometimes, for sure. Yeah, the binomial theorem works as well. Exactly. I was drawing the triangle because I think the triangle's cool. It's pretty. All right, Nick, let me see. Loading in very slowly. It's a very high resolution image. I think you have to do some weird equating for 2m plus 1 so it does 240m as well. I don't think for the IIT problem? Yes, someone did answer it. Free fire. It's in my Discord. What was it? His name? Yeah, in here. Joseph did it. Yeah, Sadud and Joseph did, so it's right here. This is your question, right? So, these awesome guys were working about it on my Discord if you want to go check it out. Factor the thing, he says. Okay, fine, I'll go factor the thing. Go factor the thing. N to the 5th minus n? Okay, what? So what? N to the 5th minus n, that's the same thing as n to the 4th minus 1? I mean, there's the basic step of, like, write something that works and then index it by 1 and then, like, try to make it look like the same thing. It is just steps, but then there's also some weird intuition you have to build for how to make certain things. Like, for instance, divisible by 240 means you need to show it's divisible by, like, I think 2 of its factors, right? It has to be divisible by, like, 3 and 80? Or maybe 3 and 8? Yeah, like, this part is always... There's special tricks for it. 3, 5, and 16. Okay. Does that help? Difference of squares? Maybe. What, so n squared plus 2, n squared, sorry, n squared plus 1, n squared minus 1? I think I want to use this part, though. I think I need something to use something with to the 5th power. I think that's why they gave that to us. Okay. I'm throwing this in ChatGPT, just because I need to understand it, and I'm hitting a wall. Especially at 3.5 hours of streaming. My brain's turning to mush. Let's see. Here, I'm just gonna throw this in. See what we get. Come on, ChatGPT. Alright, let's see. What does she say? Alright. Well, your first part's right. Okay. And then you proved it by step 1 is okay. Alright, let's look at this. Assume G2K plus... Okay, so they're calling this G of K. Yeah, G of... Okay, they're saying G of K is K to the 5th minus K. So here. G of K is equal to K to the 5th minus K, right? And so if G to the 2K plus 1 is divisible by... divisible by 240. The next odd one is 2 times K plus 1 plus 1. So that's 2K plus 1 plus 2. Yeah, okay. So G of 2K plus 3 minus G of 2K plus 1. So this is, yeah, 2K plus 3 to the 5th minus... Oh, wait. 2K to the 3... Oh, I think I see. One second. 2K plus 3 to the 5th minus 2K plus 3. And then minus 2K plus 1 to the 5th minus, so that's plus 2k plus 1. Okay. Do you see this so far, how we're going with this? Right, so this minus this is equal to this and this. So I get 2k plus 3 to the 5th minus 2. Yeah, people ask trig, I'll do it. This is minus 2k plus 2k. Then this is minus 3 plus 1, so that's going to be minus 2. Okay, and then we have minus 2k plus 1 to the 5th. And this is still equal to all this. Angel work, thanks, Carter.
Bing bang.
Okay. I'm not sure exactly why we're doing this, so just trust. And this is kind of the bullshit in induction, is you're trying to say like, oh, this equals this if this was true. And then I think we're going to show that one side is divisible by 240, so the other side must be divisible by 240. I low-key made a small development. I made them simultaneous and then subbed them back in. Yeah, maybe. Okay, and then where did we figure this out? Uh-huh. The intent of the author is to make 2k minus 1 your assumption, and then the next odd one is 2k. Okay. Thank you. Okay. Okay, wait. Yeah, fuck this. Wait 1 sec. Thank you. Thank you, Mathematic Fanatic. Yeah, I will do many more after this. Okay. Alright, let's do it this way. And I think you were right. Okay, 2k minus 1 is divisible by 40. Then the next one should be... Thank you, Mathematic, for showing that to me. Okay, so it should be 2k plus 1 minus 1. So that's 2k plus 2 minus 1. So that's 2k plus 1. Okay, cool. Oh, I think I get this. Okay. So, then g of 2k plus 1 minus g of 2k minus 1, right? This should be equal to 2k plus 1 to the 5th minus 2k plus 1 plus 2k minus 1 to the 5th minus 2k minus 1. Okay. This cancels with this. Okay, I think I see it. Fanatic helped me with that. Yeah. I was like, where the fuck is this coming from? Minus 1 plus 1. Wait, it's minus 1 minus 1. So it's minus 2. Right? Okay, so this is equal to 2k plus 1 to the 5th minus 2k minus 1 to the 5th minus 2. And then this right here is what we already did for here. Look at this, 2k plus 1, 2k minus 1, right? So by your work, 2k plus 1 was this. Right? This is 2k plus 1 to the 5th. And this was your 2k minus. Are you missing a negative sign? Yeah, sorry. I am. Sorry, minus, plus. Yeah, I was. Yeah, sorry. Minus 2k, plus 2k. That goes away. Minus 1, minus 1, minus 2. Thank you. Thank you. Thank you, jokes. Okay, cool. All right, so then we do this subtracted from this, right? So this minus this. And let's see what survives, right? Well, this cancels with this. So is that 160h to the fourth? Or 160... 2k plus 1. Yeah. 160k, okay. 160k to the fourth. This one cancels with this. And then we have plus 80k squared. And then plus 2. But then you also have a minus 2. Okay, these go away. Right? Okay. Okay, cool. Okay, so then I have G 2k plus 1 minus G 2k minus 1 is equal to 160k to the fourth plus 80k squared. Is that divisible by 240? I think so. I see. Well, 160 plus 80 is 240, no? That has to be divisible by 240, right? Yeah. Oh, wait. And this is divisible by... We assumed divisible by 240. I feel like this is good, right? This is divisible by 240. This is divisible by 240. Right, as long as it's odd. Right? Because 3 would be 240. Right? Yeah. And then 525 times... K can be any integer, so 2k plus 1 is odd. I agree. Do they? Oh, TikTok's weird sometimes. Wait, where are you getting a 52 from? Oh, you just said they're equal to each other? Oh, but by a factor of 240p? Oh, okay.
Nice.
It is proof by induction. I think we're on the same thing here with the 160M and the 80. Don't ask me, bro. Okay. Here, I'm gonna just out of essence of time, because we have been working on this for like a really long time. I'm gonna leave this where this is. I'm gonna put it on my Discord to see if anyone else wants to keep solving it. But I think we're very close here. I'm trying to think what was ChatGPT doing at the end. They're being weird. They did like 2K plus 3. Like, I don't know what all this modulus bullshit is. What's the question? Maybe I can help. Yes. Excellent. If you do want to help, so on the website here, www.actualofficehours.com, if you go to the live queue here, you can see the screenshots of all the questions that have been asked, and then if you click on this, this is his first question. Modular arithmetic is the coolest way to do this? Okay. I don't know how modular arithmetic works, but I'm going to mark this one as done just for now. And then we'll see. Just so I can make sure I can help out Ricardo and everyone else. All right. Mark is done. And then let me... Now wait, look at this. Look at this, by the way. This is what I was thinking. Look at this. So you get 160k to the fourth plus 80k squared. So 80 is 16 times 5, so we only need a factor of 3 from this. Oh, this is very cool, actually. Here, I'm going to add this little tidbit in it. I think we were on the right path here. What's the Discord link? It's the same website you use to submit the screenshot. There's a link to join the Discord. So here we got to here. I think we got pretty close. See, this was what we had, right? And then since this is divisible by 240, so you just have to prove this is divisible by 240, which they show. Oh, this is 80k squared. 2k squared plus 1. So now you just have to show this is divisible by 3. And I think they show if k equals 0. Oh, if k equals 0, then this whole thing is 0, right? So it's obviously divisible by 3. And then if it's plus or minus 1... Do I always use AI? I shamelessly use AI. Okay, cool. Alright. Ninja, good question. I'll post the solution in the Discord for you, though. It's right here in the homework help screenshots. You're going to see it in here. Cool. Alright. let me run through some more. Delete 8 3 times. Ricardo. Let's see, Ricardo. What do you got for me? What's the Discord? Actualofficehours.com. Go to that website. It has the link. Oh, okay. I think the idea is that if k squared is not divisible by 3... I'm entering the 4-hour mark of streaming, so my math skills are starting to go down. Thank you, dude. Yeah, basically then k squared plus 1 has to be 1. Okay, cool. Let b, m, and n be positive real integers. Given that log base b of 3 is equal to m and log base b of 4 is equal to n, show that log base b of this is equal to that? Oh, okay. I don't think it's terrible. So what? This is the log. These are log rules. So this is the log base b of 27 over 16 to the 1/2. That's what the square root means. So you can pull the 1/2 out. So that's 1/2 log base b of 27 over 16. And then by division rules, right? This is 1/2 log base b of 27 minus log base b. Yo, thank you, Haji. I think this has been the most donations I've ever gotten in my life on a stream. I appreciate you guys. What are we at so far? $83. Look at that. Wow. Thank you guys. You guys are awesome. The Twitch link isn't working? Really? It should be. Someone tell me if it's not. You should just go to it. One sec. Like, sorry, if I go here and I just say watch on Twitch. Yeah, no, that's fine. Yeah, there you go. Yeah, just click on the watch live on Twitch. It should work. Okay. So here we are. Bingo bango. And then I need these to be log base 3s and log base 4s. Oh yeah, Twitch is sometimes buggy for sure. I mean, YouTube always works. Or TikTok. So 27 is equal to 3 to the 3rd. 16 is equal to 4 squared. Thank you, Disinfonts. I appreciate that. Okay. So this is 3 to the 3rd. This is 4 squared. And now I can pull down exponents. Right, so this is going to come down out front. This is going to come down out front. And then bingo bango. No, dude, everyone's donation counts. Thank you, dude. Yeah, I mean, yeah, some random person came in and just gave me, I think it was like $70. Yeah, I was like, yeah, thank you. That'll definitely help fund some things. I gave out, I think, $15 worth of, no, I gave out $17 worth of prizes this weekend to students. We're a nonprofit where we help kids out with math and science, and then we also give them rewards for, like, doing well and asking questions. And then we play gaming tournaments with them, too. We did some Fortnite this weekend. I'm going to do Roblox next weekend with them. Okay. This is equal to M. That's my dream, is eventually for this nonprofit to just be, like, self-sustainable. Because then I can, like, have it do other things. And then this is N. So yeah, every bit counts. Trust. It's better than for, like, the last 4 years I've been doing this for 0. I've been having to pour my own money into it to get it to work. But that's what you have to do. It takes money to make money. You know, they say it. Okay. Minus 2n. $15. Yeah. So, okay, this is going to be 3/2 m minus 1/2 times 2, so just minus n. Is that what the right answer was? Yeah, 3/2 m minus n. Nice. I love a good victory, dude. There we go.
Well done. Well done.
Yeah. That one felt good. Some of these questions just are, Sorry, Lineatrix, you were right. The first odd integer was 2k minus 1. Yeah. Thank you. All right, Ricardo. Hope that made sense to you. Ricardo. Someone says, have you heard of Simon Singh program in the UK? He has thousands of tutors that meet students online every week. That's dope. Yeah, there's another website that I think kids use to teach each other. What's it called? Y'all know. I know you students know. Because they do it to put it on their college resumes all the time, being like, well, I tutored kids on this. But then a lot of other people say it's just absolute trash because people just do it to say they're on it, but then they're not actually good teachers. Yeah. Can we see the question again? Yeah, sure. This one? Yeah. And Mathematic Fanatic, they're all in my Discord as well. So like right here, if you go into the homework help channel, I have all the screenshots and then the solutions so far. I'm like now learning logs, so I had a bit of problems with this one. Yeah, that's cool. So Ricardo, I have a really good video on logarithm rules. If you're on TikTok, I think it's one of my most latest videos. I put it out in the spring. I need to spend more time producing short videos. I used to do these a lot, and then I kind of stopped over the summer because no one really watches educational content over the summer, and then live streaming really took over. So I've been doing that a lot. But yeah, so I think it's this. Well, it will load eventually. My potato internet today, dude. What? There we go. So here's like 4 major rules for expanding and condensing logarithms. This is a good video I have on logs. And then this is another one using logs for like tricky things. My internet's just like not loading right now, but it's here. So go check them out. Should help you out. Compared to the other questions, that one did feel really nice. I mean, I like the struggle. Like, trust me, I like the hard ones, but my self-esteem definitely feels better when I have a little bit of an easier question to solve. 100%. Okay, cool. Ammeters. Ooh, fuck. This is cool. This is actually really interesting. Circuits. I don't know if it's called SAT Schoolhouse, or maybe actually jokes. I think it is called Schoolhouse. Is that what it's called? One sec. Students tutoring other students. Not all caps. I think it's owned by Khan Academy too. Oh man, what is it called? Tutor Peers? No. Schoolhouse. I think it is called Schoolhouse. Yeah. Whatever. Okay. Oh, cool. What is the reading on the ammeter? So if this was 2R, the answer would be 0. Because you'd have equal resistance in the branches, and then the current would just like be like, why the fuck do we need to like split? Okay. So, let's think about this. Wait, so current is going to come in here. It's going to equally distribute because these are equal resistances, right? And then the current here versus the current here has choices, right? I feel like more of the current's going to want to run this way than run this way. Right? Because this is an easier path. This is a really cool question. Do I have to do like a KCL loop on this? Are there experiments where you can double check this in real life? Yeah, I mean, I could throw this into like a simulator for sure. I appreciate it, Jonas. Yeah, all right. Let me just think about it. Sorry. Now wait, there are no numbers on this though. No. Someone's asking about abelian groups, lineatrix. Oh, you just derive an equation. In terms of R and V, probably, right? Gotcha. Okay, cool. That's fine. So it's interesting. Ammeters act as shorts, right? There's no resistance. Doesn't this not work? No, it definitely works. You measure current in series. You do. So what the ammeter acts like is the ammeter acts like just a solid wire. Because there's little resistance in it, right? So the equivalent circuit you really have here you have 2R you have R, and then these things are coming together, right? Into R and R, right? So Uncle Bill says the ammeter will act like a short. 2R will almost see zero current. It will see some current, though. It definitely will see some, right? Because the resistance of like having a single resistor versus two resistors in parallel is different, right? Some current still does go through there for sure. Almost, right? Yeah. Okay, so let's think what like I total is. Oh, wait a minute. Doesn't this just measure? Oh, wow. Oh, we hit 2,000 followers. Nice. Wow. That's big. Thanks, guys. 2K. Finally. Woo! Little celebration.
Damn, man!
No, we assume the ammeter has no resistance. We assume it's an ideal ammeter. Because wait a minute. Can't I reduce this? Wait. Can't I just reduce this to a circuit? This is a circuit. And then shouldn't the current through the whole thing be the same? Right? Am I crazy? I don't know. Because they're in series with each other. Right? Yeah, that's what I thought. Okay. So this has an R. Okay, let's just call these things. Sorry, let's go like 1. Here we go. 1, 2. Well, actually, let's do this. 1, 2, 3, 4. Okay. So R34 is equal to 1 over R plus 1 over R to the minus 1. So that's equal to R over 2. This is equal to 1 over 2R This is R12 plus 1 over R, all to the minus 1. So that's equal to, what is that, 3 over 2R to the minus 1. So that equals 2/3 R. Great. Cool. Okay, so then V total, which is V here, we assume, right, is equal to I total times R total. R total is this and this in series, right? Yeah. Well, I'm just going to consider, right, this is a circuit, yeah? This is a circuit, and then these two things are in series with each other. So watch. So R total is now 4/3 R, I think. Wait, no, sorry. 2/3 plus 1/2. I'm dumb, sorry. 2/3 plus 1/2 is 4/6 plus 3/6. 7/6. Okay, is V tot. Cool. Six, 7? No, dude.
Disqualified.
Damn it, dude. No, dude, it's 7/6. What's up, Knock Void? Current through 2R and R. You're right. Yeah, you're right. But my ammeter is bleeding. Yeah. You're right. Right, that's where it's weird. It isn't, like, fully connected, though, right? Okay, fuck. Ugh. Okay, but we do agree, like, I think the equivalent resistance... This is right? This is the equivalent resistance? Right, so this is R. I'm on the right track. Okay, I'm glad I'm on the right track. Okay, well, let's think, right? So... They share... Yeah, this is like... Okay, this is like the midpoint. I guess we're calling this like M. I don't think you want to put them as 2R. No, these are in parallel. You can ignore this as just a 1/2 R for sure. So let's think about, right? So you have... The circuit is, the question is saying, find the reading on the ammeter. Okay. If this is V coming across, right? We are then going to drop some amount of voltage here, right? Across these two. To then get me to what's like VM. And then I think we drop across this to eventually get to 0. Yeah, I think I got this. Wait 1 sec. Okay. So V minus I total R12 minus VM VM is like the rest that's left here, right? That has to all be equal to 0. Okay, so VM equals V minus I tot R12. Oh, I need to extend the time. We're going for like the longest stream ever. Okay. Okay. We're getting there. We're getting there. We're getting there. This is equal to V. And then I total we figured out was... Okay, I tot equals 6 over 7R. Okay, so then R12 was 1 over 2. Okay, so this is equal to VM equals V minus 3/7. 3/7. Okay. Oh, but this... sorry, this also has a V on it. Sorry. I told equals that. V. Got it. Okay. No. Oh, wait. R12 is not 1/2 R. Yes, I agree. Here, 2/3 are. Okay, there we go. Okay, that's V minus 4/7 V, so that's equal to 3/7 V. Okay, so that's VM. VM is 3/7 V. Yeah, and let's do Kirchhoff on the little loops. I agree. Because there's no voltage source here, right? So, okay. So you want to do this one? So what, I3R minus I4R? Wow, thanks for the $5, clickbait. Appreciate you, dude.
Just donated $5
Appreciate that, dude.
Education.
Thank you, dude. Thank you, man. I'm in Struggle Street right now. Oh wait, but how do Kirchhoff on these little loops work? Because this is like a different current, right? Fuck. Right? Like, I'm assuming current's running this way. Yeah, isn't that cooked? Yeah, because now you got, like, current here, and like, all these currents are different. And then I gotta do nodes and stuff. I think I will use currents. I will use KCL. I'm not doing KVL. I don't think I'm doing KVL. Is it? No, it's not MCQ. Unfortunately, it's not. Okay. All right. Here's what we know, boys. Ladies and gentlemen. I know this right here is at V. And I know when we get to here, I'm at VM. Okay? So, looking at each of the resistors here, right? The voltage across this has to be V minus Vm has to be equal to, we're going to say like I1 times 2R. And then here, you also have V minus Vm for this bottom one has to be equal to I2 times R. Okay, and then V minus Vm is 4/7 V. Right? You think it comes out? Okay, but oh wait, watch from here, right? So V minus Vm equals 4/7 V. So this equals 4/7V. This equals 4/7V. And then we assume this is at 0 volts. So then Vm minus 0 is equal to I3R. And then Vm minus 0 is equal to I4R. Okay. And then we know Vm is equal to 3/7 V. Okay. This equals 3/7 V. This equals 3/7 V. All right. That's the currents going through everything, right? So now let's calculate from KCL. Right? Current in, current out, right? So there's current. I'm going to guess this is what... Well, okay. Not a lot of current's going to run through here. A lot of current's going to run through here. And so I'm going to gander... Well, fuck. Whatever. We just said all the directions are doing this anyways. Right? No. This question was asked 2.5 hours ago, and I got to it probably 10 or 20 minutes ago. We've had quite a queue of questions. But don't worry, even if I don't get to it today, if you submit it, it will still it'll get put into my Discord, and then other people may answer it. Like, we have a huge community. We have like 2,000 people on our Discord. Kirchhoff, oh my god. I know. I'm so close. Okay. Okay, I think I see how we do this. So this wants to match the current. This is like matching the difference in current. Right? Don't we want the same current through both of these? I think we do. I use the same VM for both points. Yeah. I'm calling it like a node, I guess. Yeah, currents, but it's like, it's reading this current. I have everything, babe. Thanks, Tim. Well, let's see. How do we do it? The meter is shorting it. Okay. Oh, wait. Oh. The difference in these two currents has to be the current in here, right? Yes. Okay, wait. Right? Current in has to equal current out. So if there's a difference between these two currents, that must be current here. Okay, fuck. I think we're done. What is it? In is positive. So 4/7 minus 3/7, right? Minus V of the amp meter has to equal to 0. Okay. 1/7 equals VA. Is that right? Is it 1/7? Am I close, dude? I've been streaming for 4 hours right now. My brain is fucking mush. Yeah, it's okay if you get negative signs. Tell us, Jones. Is it correct? Is it 1/7? Or 1/7 VR, sorry. Sorry. There's a V in it. Sorry. 1/7 V. Yeah, sorry, and then use the currents. Okay, sorry. 1/7 V. And then, sorry, this is over R. No, V over 7. Sorry, sorry. 1/7 V over R. Right, okay, because here... Sorry, I2 was equal to 4V over 7R. Here, I4 is equal to 3V over 7R. So if you subtract the two... Sorry, this is VR. VR, you get 1/7 V over R. Yeah. And that actually makes sense, right? Because look, because I1 is equal to, when this comes over, is equal to 2/7 V over R. But I3 is still equal to 3 over 7 V over R. So in this case, this is less current going in than this is coming out. So you need this current additionally coming in. And that's the 1/7 from the ammeter. To get like enough current going in to equal the current coming out. You put V over 7R, it said no? Wait, no. Did you make sure this is in parentheses? It needs to be like V over 7R, like that. If you just type this thinks it's V over 7 times R, which is not right. Yes, works. Oh, fuck yeah, dude. Nice. Good.
That's dope.
Jesus. I mean, the requests are still open, but I'm not sure I'll get to it. Toasted is next. Thank you, Olaf. Bless you. What's up, Justin? Come say hi.
Yeah.
Justin, what's going on, dude? Fortnite champion from this weekend.
Yeah.
Hell yeah, dude. Yeah. So we had a what's up?
Isn't it Renanda, something like that? He's crazy.
Cuber.
So
Cuber. You play with Cuber.
Yeah, Cuber and Shaq are absolutely crazy at that game.
Yeah. Yes. Yeah, for those watching, I do gaming tournaments with the students in our Discord too. And so Justin, who's in my voice chat right now, won this weekend. What'd you win, Justin? What did you win? What was your prize?
I got the battle pass for completely free.
You got the battle pass for completely free. So, you know, Justin, you know how many donations we've had today?
I don't know. I joined a little bit ago and I seen one pop up, but I didn't see how much.
Dude, someone donated $50 off the rip, dude.
Oh, damn.
Damn.
That's dope.
We had a lot of other donations, so I think the total's up to like $90 right now, just for today's stream.
Hey, man,
it's
at least you're making money. From it,
there we go. Yeah, I'll make money so I can buy you guys prizes.
Oh, yeah.
Oh yeah. Okay. Nice. Let me see what the next question is. Toasted. Someone give me something nice, please. Okay, I think this is kind of nice. So I have to like cock my head to see it. Unless someone's
I
like,
can tell you when you're screen sharing.
how can you tell when I'm screen sharing?
It freezes your screen and makes it like a tiny bit dark today.
Yeah.
Like today. So
Oh, yeah.
I was saying it. It makes your screen a tiny bit dark.
Yeah. No, I do see that. Joseph says, questions have been so cooked today. I have had some pretty difficult ones today. I've had to pass. I've had to punt on like 3 or 4 of them. At least probably 5 or 6. This one. Evaluate x over tan x dx. I think I have to take a limit, right? Because I can't take this at 0. Right? Don't we gotta split this? I'm echoing. Uh-oh. Why am I echoing? Is my audio still echoing? I don't think it should be. Test. No, that's okay. Alright. Okay. All good, thanks guys. Well, I think you have to take the, like, this has to be broken up into 2 integrals, right? From negative infinity to x. X over tan x. Thank you guys. Dx plus x to infinity. X over tan x. This has infinitely many vertical. Oh, right. Yeah. Wait, yeah.
You done messed up,
Yeah,
Aaron.
wait, this fucks up everywhere, dude. Yeah, what? No, this is undefined, no? Right? Yeah. What's the symbol? This means all real numbers. So this means integrated everywhere. Okay. I don't think this is solvable, but here, let's just put it in ChatGPT. I'm curious. Let's see if chat wants to do it. I think Mathematic Fanatic is correct in that because tangent of x will be equal to 0 periodically, very often, you're going to get a bunch of undefined shit happening. So, yeah, I don't know if this is... But maybe symmetric. You think it's 0? Yeah, it has periodic singularities. Yeah. But maybe it's 0 due to symmetry. Okay. They're saying if the limits are 0 to pi, then it's x cotangent of x, and you can do integration by parts. I agree with that. If it was intended for all real, ChatGPT says it does not converge because of the poles. Okay, cool. Glad we can, like, knock that one out. Oh. TikTok's mad at me. I know, baby. There you go. Was this toast? Toasted? Nope. There we go. Okay. I agree, I think it's 0. Did Toasted have another one? No, we already did that one. Okay. Mark that one is done. Alright. Amy? What's up, Amy? Oh, these are nice. Oh, I love these. Oh, these are beautiful. Cool. Okay, let's see. These aren't bad. I think you just have to get these in like slope-intercept form, right? So for this one, I'd multiply everything through by 5. Just like multiply the whole thing by 5. So you get 5/4 x minus y is greater than 1. Then move this to the other side, move that to the other side. So you get y is less than 5/4 x minus 1. Okay. Draw what that looks like. So that's a y-intercept at minus 1 and then goes up 5. 1, 2, 3, 4, 5 over 4. So that's that. So then you have, oh, and because it's not solid, right? You gotta be careful. So it's a dashed line. And then, I mean, if you look at less than, that's kind of easy. Less than is always like kind of like below the line. So that's going to be like down here. If you really wanted to test it, you should like pick a point. So for instance, like 5, 0. And you'd see that that would be true, right? That would be 25 over 4 minus 1 is greater than 0. So that's good. That's easy. This one's interesting. So for this, you get y is less than or equal to x minus 4. So you move that over, move that over. So x minus 4 would look like here. And it would be going up by 1. Cool, like that, right? But then there's some requirements here. So usually it's down here. However, x has to be greater than 0. So that you can't have this region. Okay, so you have this. You have to draw like some other lines. So you have this right here. And then y has to be less than or equal to. So this one means solid line. -2. Okay, so then it's this region. Okay. I dare to use a matrix to solve the system. Which system? I've done many systems. Okay, this one's nice too. So +2, -1/2, so down 1 over 2. Cool. That's a solid line. And then it's greater than, so it's gonna be up here. But x also has to be greater than 1. So you draw another dashed line here. Or, sorry, it's a little cocked. X equals 1. And greater than y equals 1. Cool, so it ends up being this area. Nice. Love it. That one's pretty simple. Let me know if that made sense to you, Amy. Okay, nice. Next up, clickbait. What's up, clickbait? Oh, but this is a triple star question, clickbait. Oh, dear. Oh, I know this question, too, by the way, clickbait. I've seen this one before. What gift do I send to move up the list? I don't know. Something that's worth, like, a couple bucks at least. What gift is worth a couple bucks? Someone sent me, I don't know. I know the roses aren't worth very much. I'm new to like TikTok gifting stuff. Consider a mass. Six questions so far. You can see there's a timer. I got 30 minutes left that I'll do. If I don't get to your question, it'll get put in our Discord, and then it may get answered later. Maybe. Yeah, I mean, it doesn't hurt. Like, submit it anyways, and then join our Discord, and it may get answered later. Depends how hard it is. This is already, like, making me hurt. This is a triple star question clickbait, by the way, too. Any grade, yes. I mean, you can see the last question I did was graphing, like, inequalities. This is pretty, like, not too great. But then, like, also, like, we get into some... We did, like, some circuits earlier. This was some basic math. This was a little bit harder. Yeah, grade 11's okay. Yeah, submit it, dude. Shaking my damn head. Yeah, dude. Fuck. Alright. Oh, okay. Discuss stability. So... in cylindrical coordinates... I mean, I can think about the forces on this thing, right? So I have the force of gravity that just points straight down, right? Do we say that it has a mass without friction, right? Okay. So that points straight down. And that's it. That's the only force, right? However, you then also have acceleration pointing inwards. And that's equal to v squared over r. Which, in terms of omega... v equals r omega. V squared equals r squared omega squared. Okay, r omega squared. Cool. So, yeah, and then this is moving at omega. Okay, so let's come up with some, like, equations. So I know that, like, phi of t, that has to be equal to omega t, right? And then its z position which is, oh, that's rho, that's x. Oh, but that's the same thing as r. Oh, okay, cool. I'm gonna say that, okay, whatever, z of rho is bound to k rho squared. Cool. Oh, that's pretty good. Thank you, dude. Money gun. What, sorry. What's your name on the... I'll do your question after this, because you did send me money. But which one are you, then? $2 is significant. I'll take $2. Oh, no name. Okay, no name. Cool. What does the K and the rho stand for? Sure. K is just a constant, which kind of describes the curve. And then rho here describes the radial distance from the center of the rotation. Okay? And that's important because eventually we're going to say, like, centripetal acceleration is dependent on your r from the center, which is rho, right? Okay. So, remind me how I write a Lagrangian. Okay, yeah, send them both, no name. Okay, L is equal to KE minus PE. Why is it not dr dt? Isn't that easier? No. Rho is the position. Okay, so, in cylindrical coordinates, v squared is equal to rho dot squared plus rho phi dot squared plus z dot squared, right? This is like this is like dx dt, but in cylindrical coordinates, because you have three. Now you have three different axes you have to worry about. The theta direction, right? This is kind of like the arc length thing component that comes from. This is like moving transversely, horizontally, and then this is vertically in the z direction. Okay, but then we have some restraints on this, right? So if phi is equal, if 5t is equal to omega t, that means phi dot is just equal to omega, right? V is velocity. So it's like, because eventually with the Lagrangian, what we want is kinetic energy, which is 1/2 mv squared, right? And then we're going to subtract that from the potential energy terms, right? L is equal to KE minus PE, right? And kinetic energy is always 1/2 m x dot squared, but in cylindrical coordinates, you have velocity in a bunch of different directions. So the magnitude of that velocity, which is a scalar, needs to be like the magnitude of all the components. Yeah. It is like x, y, z, but it's in cylindrical, right? So it's r phi z. This is the velocity in the phi direction. This is in the z direction, and then this is in the r direction. Right? Cool. Okay, so that means, but then we have restrictions, right? That equals that, and then z was equal to k rho dot, right? So, z dot is equal to 2k rho dot, right? That's going to be a, that's a, what is that? That's a chain rule, right? Okay, so now I'm left with v squared equals rho dot squared plus rho omega squared plus 4k squared rho dot squared. Here, and I think we can start like moving some things around, right? Okay, so this is equal to rho dot squared plus actually no, let's group these two. Rho dot squared 1 plus 4k squared rho squared plus rho omega squared. Rho squared omega squared. I am still going, fem. They are partials, but it's with respect to time, jokes. Okay. Because t is 1/2 mv squared, right? So in that case, that's going to be 1/2 m times all this. And then the potential energy term is just equal to mgz, right? This is equal to mgh, which is just mgz. But then z is defined as k rho squared. Magic harp. Okay, cool. So the Lagrangian, which is equal to t minus u, is equal to this thing. Right? Minus mgk rho squared. Okay, cool. Part A. Find the equation of motion. Okay, so to find the equation of motion, yeah, you said it here. I have to say dl... Yeah, dl... I have to have my generalized coordinates, which I think I'm doing in terms of r, right? Yeah, okay, so by what clickbait sent me here. Come on. It's a very, very low resolution image, dude. What? Okay, fine. Yeah, there we go. Okay, so dl d rho is equal to d dt of dl d rho dot. So in terms of rho dot here, this will survive. I don't think anything else really survives, right? And then, yes. Okay. DLD rho dot is going to be M rho dot, right? Because this comes down as a 2. And this is 1 plus 4k rho squared. That's it. Okay. And then the other one you need is DLD rho. So let's do this one. DLD rho is going to be... It said 2K earlier. We keep like gaining and losing followers today. We hit 2K. It happened. It happened. 1/2 m rho dot squared. And then this is going to be 8k squared rho from here. And then plus m rho omega squared minus mgk minus 2 mgk rho. Cool. All right, and then that has equal to 0. Oh, and then it's DDT of this. Oh, no. Oh, no. Sorry, this is just DLD rho, and then we do DDT of that. Oh. Yeah, I have a video on how to graph polynomial functions. Check my it's one of my most popular videos on my main TikTok. Right, okay. So this was just DLD rho dot. Sorry. Then we still have to do DDT of this. Okay, so I do this 5 days a week, yeah. And then this is plus... This is a product rule, right? This is m rho dot 8k rho dot. Okay. Jesus. Okay, so m rho double dot 1 plus 4k rho squared plus m rho dot 8k rho dot minus 1/2 minus all this has to be equal to 0. Okay, and then assumptions we're gonna make, because I think we say it's at equilibrium, no? Right. Whatever. I could find the equation of the motions, but like it's a huge pain in the ass. What level of physics is this? Come on, internet. Am I a mathematician? I'm a physicist. I'd like for my stuff to play, please. More music. Wait, where did my whole other question go? Okay. Discord might be killing my frames, maybe. Oh wow, yeah. What happened to all my frames? Yeah, let me kill my frames real quick. Stop streaming on here.